in the world. What up, everybody? Thanks for kicking it. We got 250. Smash the Rogans up. Because, we got algorithms out here trying to hold us back. All right, so Brian and I are going to have a little debate. The two primary subjects will be the spin, or shall I say the alleged spin, of the Earth and gravity. We're hoping to have it be cordial and respectful. Last time he kind of had to go 4v1, so we want to give him a fully fair opportunity to voice his side. And we will, barring how the time goes, have a Q&A session at the end. So we ask everyone that is going to super chat a question to be read off the Q&A to be respectful, no insults or personal attacks. If you have a specific question for me or for Bryant, then you can super chat it and we'll read them off. But like I said, try to be respectful, and also try to be respectful in the chat because, truth doesn't fear investigation. There's no reason to stoop down to any type of vulgar behavior. Okay, cool. So there is the opening. Jaron will be modding. So without further ado, let's add everyone in. Wow. How's it going, gentlemen?
Doing great. That was a great intro, by the way. That's even though I don't agree with the premise. This will be fun.
And just to piggyback off what Austin said, make sure if you're in the chat to try to be polite. Maybe think of Brian as your grandpappy or something. Just be respectful. We don't need to attack the person. Attack the argument if you want to attack anything. And
not that old yet.
No, well, close. Maybe
I'm getting there. 52 is not.
That's grandpappy age. I'm telling you.
Yeah.
So I guess the way it's going to work is we're going to just have each guy give 10 minutes to give their opening, and there'll be no interruptions. So it should be pretty simple from there. And I think you're going to start, right? Right?
Yep. I'm going to start.
Do you want to tell people who you are real quick?
Oh, yeah. Bryant Meyers, actually a former physicist and teacher. I did teach at Central Michigan University, so I actually was a college professor. I've been really into energy medicine, post-electromagnetic field therapy. I have a best-selling book on that topic on Amazon. And it's basically magnetic fields that change with time, and it has tons of research. It's been one of my main passions the past, I would say, 15 years or so. I'm a passionate. I love science. I read science for fun. So I had a lot of friends that got into the flat Earth movement, and I did look into it and the claims, and obviously my side. I mean, I feel the evidence is overwhelmingly on the globe side, but that's just my position as a physicist. And I'm hoping to, in these two departments of gravity and spin, present that evidence. And
Word. So Jaron, I think you just, whoever's talking, I guess, presenting, like, just make them big.
Okay.
We'll just kind of do it that way.
Okay. And
did you say there's a sound problem, or is everybody on the same level?
Someone complained about the levels of the mic, but I don't know. A lot of people were saying it sounds fine. So, there's always the one person that does that. So
yeah, we love that.
I think we're good. Sounds pretty equal to me.
Oh, it just says Brian needs to get closer to his mic. So I remember last time you said that you thought you were a little quiet.
I think he sounds fine right now. Will you say something?
He's joking around. That was mute. He was muted.
Oh,
you're muted.
I think you.
Oh, can you hear me now?
Yes, now we can.
Yeah.
Okay.
I'll turn you up a little bit just because I think you're going to be quiet. But anyway, go ahead.
Yeah, it's just I got to get used to these mics and keeping I like to just kind of go free for all. But just tell me when we're going to start, and
good. I got you a little higher on your mic, so you should be all right.
Okay.
Ready to begin?
Well, all right. Well, great. So we're going to start with gravity. And I just wanted to begin with a quote by Albert Einstein. No one must think that Newton's great creation can be overthrown in any real sense of this theory of relativity or by any other theory. His clear and wide ideas will forever retain their significance as the foundation on which our modern conceptions of physics have been built. So that's Albert Einstein. And I just want to, before I get into my my presentation on some of the evidence that I have for gravity, I just kind of wanted to lay down University of Berkeley is kind of this idea of a scientific law, because it does seem there's a lot of confusion on what a law means in science. And in everyday language, a law is a rule that must be abided by or something that can be relied upon to occur in a particular situation. Now, scientific laws, on the other hand, are less rigid. They may have exceptions, and like other scientific knowledge, may be modified or rejected based on new evidence and perspectives. In science, the term law usually refers to a generalization about data and is a compact way of describing what we'd expect to happen in a particular situation. Okay, so Newton's universal law of gravity, let's just start here on Earth. Things like bridges, roof systems, stadiums, aircraft hangars, bridges, auditoriums, building structure, bike frames, ladders, scaffolding, pliers, scissors, automobile suspensions, just equipment, planes, trains, automobiles, just the structure of the world around us is based on Newton's laws of gravity and Newton's, 3 laws of motion. So I just wanted a little show and tell here. At Georgia Tech, I was electrical engineer, and I had to take these classes called statics and dynamics. And this book right here is 1,400 pages of just using basically Newton's laws, no electrostatics, pretty much just all Newton's laws of motion and Newton's laws of gravity. So the world around us is living testament that Newton's laws work. And this is what a scientific law is all about. It's about things that work. It's not about trying to explain why they work or necessarily the deeper meanings behind them. That's the job of a theory, and those also can be modified. So I had a little fun last night. One of the beautiful things that I like about Newton's laws is they're so simple. And again, you don't have to really follow along. It's actually not that hard to follow along. So, Newton's law of universal gravity is G m1 m2 over r squared. And here I have me and m. So that's the mass of the Earth and a small m, which you'll see in a minute why I'm doing it this way. And now we can rearrange this kind of in a clever way that F equals ma, as a lot of people know from school, right? We all heard that equation. So if you regroup the first equation up here, and you see that you get your little m out, the rest of it is a. Oh, I'm sorry, over here. So this basically, you can now then say, okay, that's the acceleration due to gravity. Just very simple. So this g here, this little g is our well-known 9.8 meters per second squared. And to complete this whole process, all we need to know is big G and the mass of the Earth. And this is where the Cavendish experiment comes in, and Cavendish-like experiments. And it's just kind of worth noting down here that the acceleration is also, you can say it as F over m. So if you have a small mass, that's going to have a small force acted on by the Earth, and it's going to accelerate the same as a big force with a big mass, because the acceleration due to gravity, or the force, is more on a bigger object or a more massive object, but the inertia is also more by the same exact amount. This is why all things fall at 9.8 meters per second squared. So it's really cool. And we can even take these laws, and this is where the universal motion comes in, and we can derive Kepler's laws. I mean, I won't get into all of them because I don't have time. But Kepler's laws basically said there's 3 laws. The first is the ellipses. The second is equal areas and equal times. But the third law, he didn't know what this proportionality constant was. So we can actually just use Newton's laws, and then we just know that the centrifugal force is going to balance the gravitational force, and we can get an exact number for that constant proportionality, and all the planets fall in a straight line. So again, we don't have time to get into it, but it's really nice that this law of gravity here on Earth extends to our solar system. One of the first scientific ideas that got extended beyond just the Earth. So let's look at just Cavendish real quick here. We don't have a whole lot of time to go through it, but the Cavendish experiment here, let's just look at the experiment. Basically, there's 2 large masses that are fixed, and you will have 2 swinging smaller masses on a swinging torsion scale. As the smaller masses are attracted to the larger ones, they twist the wire, and that twist, along with the oscillation times, allows us to calculate G, the gravitational constant. Once we have G, the gravitational constant, we can then determine the mass of the Earth, and based on some of the equations that you just saw. So now I just kind of want to go through, and by the way, it's not just Cavendish. There's other. Oh, can we share my screen now?
Mm-hmm.
Yeah, thank you. Can you share my screen?
I don't know. I only have a remove. There you go. Thank you.
Oh, there you go. Yep. So anyway, besides Cavendish, there were other measurements of G, totally different ways, and they're getting the same number. This is a kind of a key theme here, is that we can calculate the gravitational constant in many different ways. And now, but I want to just look at a few modern day Cavendish experiments here, because these are the ones that are just so very accurate. And I know some of the rebuttals of some of the flat Earth enthusiasts will say, but you got to understand these tests take everything into account. The exact, the balls are perfectly homogeneous. The dampers, they put coatings to eliminate the electrostatic effect. A thin gold layer is very, very carefully done to ground it out, no electrostatics. The air density, thermal effects, electrostatic is also shielded and grounded. And then the magnetic effects, they'll use mu steel shields on the balls, and mu steel blocks magnetic fields. And here's just a little table. You can see all of these different, and they know all of the things that can lead to inaccurate results, to incredible accuracy. So there's been a lot of different Cavendish-like experiments done over the years. And recently, there's actually now about 200 to 300 peer-reviewed Cavendish-like experiments. And here we have the Committee on Data for Science and Technology, that the CODATA, which lists here the most accurate, most careful experiments, and they come up with a value for G that's around 6.67 times 10 to the minus 11, but it's out to 4 significant figures. That's incredible accuracy. And from the lowest, if you swing all the way back and forth from side to side, that's only a 0.07% difference from the highest to lowest. So it's incredibly accurate. But interestingly, other constants of nature are more accurately known. It's just gravity's one of the most difficult to measure, but it's still very accurately measured. So based on time, we don't really have time to go into the details of all these, but I did set up a page on my dfe.net, my debunkingflatearth.net site, and /G, you can see these studies. I got 12 really good peer-reviewed studies, and they're not all Cavendish, but a lot of them are. And you'll see that these, like I explained just a little bit ago, these were all incredibly carefully done, meticulously. And the fact that they're all getting almost the identical number, if you had like electrostatics or magnetism or other confounding variables, you would be getting wildly different numbers from test to test. You would not be getting this precise numbers every single time. And just look at the precision here. They're putting these in vacuum chambers. Some of these experiments did them almost near absolute zero. Just absolute incredible accuracy. Now, this is one test I wanted to share, because I've heard some flat Earth enthusiasts will sometimes say, well, that's just a man-made piece of equipment. I want to see something in nature where mass attracts mass. Well, here you go, the Mount Schiehallion experiment, which also has been done multiple times, and even recently, there's been a more recent study with the Mount Schiehallion back in what year was it? It's a much more recent analysis. And again, this particular study that was done more recently came up with a density of the Earth that was very, very accurate. And Mount Schiehallion is just very symmetric, so it makes it very easy. So anyway, we're just kind of running out of time here, but you can just check out my link, and I have a lot of good other things you can see. And don't really have. Oh, this is from Statics and Dynamics. These are the kind of free body diagrams that you need to know. And in science, like bridges, this can be life or death if you do not construct these bridges properly. And by the way, it's not just G, it's actually mg, and it's you can't just use G alone to build these things with statics and dynamics. And so we're out of time, but I didn't have time to get into Einstein's gravity, but I think we can talk about that later.
Okay. And Austin, you gonna go? You're not sharing your screen, right? Okay.
Well, I do want to let me just share the screen real fast. I want to play like a couple seconds of this video. All right. So, yeah, when you start it, I'll just play this video.
Yeah,
stuff. Hopefully they can hear it. I don't know.
I will now show you a short video of former MIT physics professor Walter Lewin.
Oh, wait. No.
Mike is gone.
Quite clearly.
So what holds our world together? Well, on the nuclear scale, 10 to the minus 12 centimeters, very important are the nuclear forces. On an atomic scale, up to thousands of kilometers, it's really electric forces that hold our world together. But on a much larger scale, planets and stars and the galaxy, it is gravity that holds our world together.
Yeah.
And now you may say, that's very inconsistent with what you just told us. Because didn't you tell us that D cancels? If you compare.
All right, anyway, that's enough. All right, so there you go, explaining up to 1,000 kilometers, everything you observe on the Earth is electric, everything that you observe on the Earth. It's 10 to the 26th, some argue 39th power stronger than gravity even claims to be. As for this law, talking point, downward acceleration is an effect. So not everything goes down. Sometimes things go up, but there's a downward bias on the Earth. I actually agree with that. 9.8 meters per second squared is agreed upon average. It doesn't happen every time. Objectively, it doesn't happen every time. It changes. It's just an agreed upon average. It fluctuates. But we use that convention so that we can build things like bridges, etc. You can replace little g with the letter A, acceleration. You don't need it. You don't need the cause, claim, effect. Talking about Kepler's law, that's planetary movement of bodies. This is a whole different conversation than what we utilize on the Earth for everyday use cases of downward acceleration. It has nothing to do with planetary movement or this idea that there's bending and warping of space-time. In fact, Newtonian physics isn't even used anymore. It doesn't work. It was debunked. It doesn't work to explain the solar system, much less further than that. So when we talk about what's on the Earth, well, we're talking about, we want to use science. We want to actually prove things. Okay, so when they proposed the globe, they thought, well, the only way the Earth can be a globe is there has to be something called gravity. That's the actual evidence for gravity. So if we want to say we have a dependent variable and naturally occurring observable phenomena, things go down. Things go up and down. So things have direction or different vectors. So what causes something to go down? Well, let's figure it out. Everything that goes down or up, everything that exists in the world is electrostatic. So all molecular and intermolecular attractive forces are electrostatic in nature. So anything going up or down is electrostatic. So let's manipulate the variable of electrostatics and see if it can actually affect the direction something goes. It does, objectively. Things go up and down relative to the electrostatics. The electrostatic field, you have electrostatic induction that goes to the object, and that relationship will cause things to go up and or down. We have all kinds of things that happen in nature that show us this. In fact, bumblebees actually levitate over flowers, and seeing as they accumulate positive charge, which there's actually no such thing as positive and negative charge. You have charge and discharge. It's a convention. There's nothing negative in nature, but that's a different conversation. So it gets positive charge in the air. It floats over the flower that has negative charge, and the pollen will actually levitate up to the bee and stick to it. Okay, so we watch this happen all the time. The clouds, of course, are electrostatic, and then based on the charges in the clouds, that's when eventually the water will come down. Right? So based on density and buoyancy alone, or based on gravity alone, there's no reason for those clouds to be up there sitting the way that they do. Now they just claim that it's basically counteracted. So whenever you talk about the Cavendish and you said that they control the variable of electrostatics, well, you said no electrostatics. That's not true. There's no such thing as no electrostatics. The gold that they use is electrostatic, right? So we have things that are called dielectric materials because they have small amounts of magnetic permeability, right? They have high levels of dielectric permittivity. They maintain their charge very effectively, but that doesn't mean that there's nothing there. Just like there's no such thing as anything being neutral. If something's neutral, it doesn't have a net charge, but it still has a charge, including all these quote unquote nuclear forces and the neutron. They have elementary charges, and everything that exists has a charge. So there is nothing in the world, nothing that doesn't have electrostatics. In fact, whenever Cavendish first did his experiment, he didn't even account for electrostatics. I know people personally that have done it, and they know that electrostatics will indeed make the balls move around. It's the primary thing you have to worry about because of the fact that you have attraction and repulsion with electrostatics. You can never eliminate it. And so then, well, what are we observing? You said that it's always the same. It's not always the same. It varies. It's such a small change, though, that you get a decent little window and you can say, oh, look, it's pretty accurate. It's never exactly accurate. And then whenever it's not, people just assume it's user error because even the slightest bit of energy or motion transferred to the Cavendish mechanism will actually affect what you see. So you didn't account for electrostatics. If you manipulate the variable electrostatics in Cavendish, you will literally get the cause. You can't eliminate it. If you ground something, it still has electrostatics. If you put it in a Faraday cage, it still has electrostatics. There's no such thing as eliminating it. And it's 10 to the 36th power or 39th power stronger than gravity even claims to be. So all this stuff about 9.8 meters per second square, that's an agreed upon average. It's not consistent. That's just an effect. It isn't exclusive to the idea that the Earth is a gigantic ball with bending and warping of space-time. It's not different on a flat Earth or a globe Earth. If things fall down, we have an agreed upon average. That's the effect. What's in contention, what gravity is the claimed cause of that effect. That doesn't mean anything. Like I said, you can change little g and you can replace it with a. So what we know to actually be true, and I just show you Walter Lewin from MIT explaining it, everything up to thousands of kilometers, which I don't make claims about thousands of kilometers because I don't believe in fairy tales. But the point is that everything on the Earth is electrostatic, and it's just objective, and we can manipulate that variable. We have spider ballooning. They proved that they took them outside of the wind because they used to think that they did that because of wind, and actually based on electrostatics, they levitate more effectively. They basically fly because they propel themselves with electrostatics. Bumblebees are not aerodynamic, but they use electrostatic resonance, and they can fly through crosswinds up to 60 miles per hour unaffected because they have like a little electrostatic force field. So what we have, I'll use the last 3 minutes to explain this. All the stuff of just begging the question of gravity doesn't mean anything. Conflating the cause and effect of downward acceleration to being the cause, which is claimed to be gravity, doesn't mean anything. Just saying, look, we have an equation that we can use for technology based on 9.8 meters per second squared doesn't prove gravity at all. Like I said, you can replace a little g with a. So what we actually see is that we have atmospheric electricity on the Earth. So we have an increase, equipotential increase. It goes up 100 volts per meter. Okay. So there's positive charge, potential charge increasing up from the surface, 100 volts per meter. Now, the only way that that can be replicated or accomplished in any way, in any actual demonstration in the world, is you have to have two Gaussian surfaces. You have to have a surface above and a surface below to get that equipotential increase. It's the only way. There's no other way that can be demonstrated. Well, we have that on the Earth. We have equipotential increase, which means there has to be a surface above us acting as the second Gaussian surface, and that's what gives you this downward flow of electricity on the Earth. So that's what gives you the downward bias. So when something fluctuates between 9.8 meters per second squared and 9.73, well, okay, because electrostatics is super weak. So the change in electrostatics would never be drastic. It's an agreed upon average. Not all things go down. Sometimes things go up. So we can actually manipulate that variable. We can prove it's there. All matter has it. It's tangible. We can actually manipulate it in an experiment and prove that it causes things to go up or down. So what we have from the beginning is scientific evidence that has demonstrated objectively that electrostatics is always present and it causes things to go up and down. And we have an electrostatic field in the Earth with equipotential increase, and there's a downward flow. You can, in fact, run something called a corona motor, electrostatic motor, with this current. Okay, so we have downward flow pushing down to the surface of the Earth where we have negative surface charge. Again, this is how bumblebees operate. So if we're going to make an additional claim, because like I said, not to be too reiterative, but 9.8 meters per second squared doesn't prove anything. That's just an effect. That's the agreed upon average of downward acceleration. That changes a little bit, but it's just an effect. So we want to find out the cause. The question is, does gravity exist, and is it the cause of the effect? That's the actual point, right? Well, when you say you try to control for the variable of electrostatics and stuff like that, you can never eliminate it. It's always there. It's 10 to 36 power stronger than gravity even claims to be. How could you find a force much smaller than that if you can't actually get rid of that force when you know it's stronger? Okay, and we can scientifically prove it. We cannot scientifically prove the bending and warping of space-time. No one's ever manipulated space-time. They just manipulate mass, reify it, beg the question, assume that it's true. So one of them is scientifically valid and can be proven, and then one of them just has to be true if the Earth is a ball and has never been proven. So in summary, like I said, people often conflate big G and little g. They just invoke 9.8 meters per second squared, saying that it proves gravity, but it does not. And Newtonian physics is not what the globe Earth model uses anymore because it doesn't work. And the reason that they didn't just acknowledge the natural intrinsic electrostatic nature of all things, and that's why things go up and down, is because it's way too weak to cause gigantic planetary bodies to move around each other in a vacuum at vast distances. And that is the only reason that something else was come up with. And there's no empirical scientific evidence for it, but there is for electrostatics. It can be manipulated as the IV, and you can prove it. There you go.
Okay. Now 5 minutes.
Yeah.
You're gonna go first, Brian.
Yeah, I'm gonna go first. Just to
5 minutes.
5 minutes, yep.
Go ahead.
Okay, well, we only have 5 minutes, so I'm just going to go through, from my understanding, I mean, this is just my time, but that it's density and buoyancy or electrostatic, incoherent electrostatic acceleration, and density and buoyancy takes care of the rest. So the density and buoyancy are still there. So let's first look at the problems with density and buoyancy. So the problem number one is things that are more dense and less dense fall at the same rate. And I actually did an experiment with a lead ball and a cue ball. The lead ball was 7 times more dense than the cue ball. And I got up on my ladder and I repeated, and I'll videotape it if anybody wants to see it. And I dropped it again and again and again. They both fell at exactly the same time, every single time. And again, you hold both in your hands, and the lead, you can tell it's like 7 times more dense. Second problem with density: things should fall faster further up as air resistant is as the air is less dense as you go up in altitude. But we know the downward acceleration slightly decreases with altitude because, again, little g, we got the formula for it right here. It's a very simple formula. We can actually calculate very accurately the gravitational acceleration at any distance above the Earth's surface. And the only thing that we have to account for is the centrifugal force, which does vary that from the equator to the poles. But once you take into account the centrifugal force, everything is very smooth. The gravity is very constant across the surface, and it drops off by 1 over r squared, big R. That's the radius of the Earth. So you got to be a radius of the Earth distance away before you get a 1/4 drop off. Now, density is a scalar with no direction. Gravity is a vector. So we know, but I know you guys use your incoherent acceleration to try to give the vector there. Here's another thing. Density towers break down in microgravity. If you've ever seen some of the images of that, you can see that the density towers don't even work when you got a zero gravity. Now, the problems with buoyancy. Can I share my screen here for just a couple minutes, Jaron?
Yep. Oh, got it. Thank you.
Okay. So the problems with buoyancy is that buoyancy literally is defined by gravity. I mean, the actual formula for buoyancy is it's the density of the surrounding fluid times the volume, which gives you m. That's units mass times g. That's gravity here. So it's basically mg, and it's not just g replaced for a in these books. It's mg. It's the weight. So you got to incorporate the mass there too. And you can see right here a great little demonstration of this is in like a free fall environment. So when you take out gravity, you can see buoyancy doesn't work anymore. So again, this shows you buoyancy depends on gravity. So we got over that. So now I want to get into electrostatics here from our remaining time. So, and I'm not going to have enough time to get through. We can talk about this in our discussion. So there's some catastrophic problems with electrostatics. I say catastrophic because they are. So gravity depends on mass. Electric field depends on charge. Electric fields and electric charges can be shielded. Gravity cannot, provably. Shouldn't we be able to step inside a Faraday cage and levitate? We can shield electric charges. Why don't objects of different electrical charge or magnetic properties fall at different rates? I mean, we know this. Different diamagnetic and different conductors versus insulators. I mean, in electric fields, they would have forces acting on them in different ways. And again, why do magnetic, paramagnetic, and diamagnetic objects all fall at the same rate? So again, you can get a magnet or a non-magnetic object, and gravity will pull them down equally every time. Electrostatic charges can be attractive or repulsive. Gravity is only attractive. The source of the electromagnetic attraction and how it works on, So what is the source of this electromagnetic attraction? How does it work if bulk matter is neutral? So again, I got my little thing here. I wanted to have Austin, oops, it's my camera here. So we want to kind of go over this side here. We want to get an F equals something up here. I'm sorry, share my screen real quick. I just had just a couple slides here that are important that I just, So the problem with this too is the fact that these electric fields that Austin talked about, they fluctuate wildly, and that at about 30 kilometers, it's almost zero. And we know gravity keeps going beyond 30 kilometers. So it just doesn't work. It doesn't match reality at all. In fact, the electric field changes not only around thunderstorms, but around, the time of day and the seasons. So again, we can get into this in discussion.
Okay, Austin, you're up for 5.
All right. So I never claimed. So you started off talking about density, why density does. Oh, it says the host says, oh, never mind. So yeah, my bad. I never claimed it did, right? Like density is one thing. You can't have density without electrostatics. So everything that has density, and if you look at the periodic element chart, I don't necessarily believe all the atomic theory, but it's a convention. It obviously there's a correlation in density and electrostatics. That's why it's one of the main variables addressed on the chart. But anyway, density itself isn't the full answer. I actually agree with that. Your examples aren't particularly great, though. If you use 2 different densities and you drop them, well, you drop them from a few feet above the Earth. And they're going to go roughly the same distance down. The primary thing to figure out, what is the determination of the vector? What determines the direction itself? Once it goes down, then, it's agreed upon average. I mean, until you drop something 5 miles in the air in a vacuum chamber, you really don't have much to stand on. And dropping it just a few hundred feet in the air doesn't really mean much. And again, downward acceleration does change drastically. We use gravimeters all over the Earth, and it's different all over the Earth. The downward acceleration of little BB using interferometry. They also have spring-loaded ones. They show different rates, actually. So it's not this magical, consistent 9.81 meters per second squared every time. That isn't true. That's like a misnomer. I don't know why people say it. But yeah, so it's not just density, but whenever there's a density of an object relative to the density of the medium, that's going to determine direction. That buoyant force that's resultant is much stronger than electrostatics. And in fact, of course, it's even stronger than gravity. Right? Even in this theoretical idea that there's gravity here, this other type of gravity, because actually gravity means gravitas and weights. Anyway, the buoyant force is stronger. It goes up and down, just like the elastic velocity, the kinetic energy of gas. It's stronger than electrostatics. What it does is it sets the bias. So even if we have slight fluctuation in thunderstorms or lightning or whatever, it's very weak. It's very weak. Like when you use a Van de Graaff generator and you make like a little paint chip float or a piece of paper, you can use iron, you can use all kinds of stuff. That's like those little chips are equivalent to like Mount Everest. Right. So the point is that it's very, 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 very weak. It just sets the up and down. That's why you wouldn't see much of a change in downward acceleration, because it would have to be such a drastic manipulation and variance to get any type of difference. But that's not the question. The question is like, what actually causes it to go up and down? And there is no problem with electrostatics other than it's not strong enough to make the Earth spin around. And you said something about at a certain height, right? Like, so you're talking about like at a certain height it drops off. I don't believe any fairy tales above 50, 60 miles or anything like that. But all of it has electrostatics. Even in the globe paradigm, they claim there's something called the ionosphere. And that it starts right at around 40 miles. They say 40 to 50 miles to like 400 miles, which we don't believe stories past 60, 70 miles at all. But the main thing with that is, that was the first time ever that was claimed. Maxwell actually changed his equations, right, to say that you could have electrostatics without matter, because you can't. You can't have electrostatic induction or electrostatics without matter. And they made up the ionosphere to basically save the globe. But the primary point here is we have equipotential increase from the surface up, and that creates a downward flow. And the only way to have that is to have 2 Gaussian surfaces. So what we know we have on the Earth has to be there because of 2 Gaussian surfaces, and that is 10 to the 36 power stronger than gravity claims to be. So I don't know why it's so hard for people to accept it, but it just is what it is. And this is why it's not discovered on the quantum scale at all. There's no evidence for gravity on the quantum scale at all. It doesn't work. It's incompatible. The relativity doesn't work at all on the quantum scale. But we know that there's electrostatics there. It's everywhere. And a Faraday cage does not block electrostatics. Sure, it can stop like electromagnetism. It doesn't stop electrostatics. The cage itself is electrostatics. The air inside of it's electrostatics. Whatever objects are in there are still electrostatic. There's still electrostatic induction. And no matter how much you try to neutralize it, like on the very smallest scale, right, which you can't remove it, because if you removed it, you wouldn't have the matter in the first place. On the very smallest scale, it's 10 to the 36 power stronger than gravity claims to be. And Cavendish is super inconsistent, of course, but it doesn't even matter. So the primary point here is we need actual empirical evidence that you're isolating something outside of it, and you're not, and it isn't completely constant. So it's somewhat reiterative to my first 10 minutes, but it's the same point. I'm not claiming that it's density alone. Buoyant force is much stronger than electrostatics, but it's what sets the up and down. It's measurable, it's testable, it's provable. All matter that exists is electrostatic. Not one piece of matter can be invoked that isn't electrostatic. And so that's all there is to it. There's there's not really even a debate to be had, because until we have like other empirical evidence to substantiate the idea of the bending and warping of space-time, which is considered to be incomplete at best, right? And there's really not much to discuss other than we need it. So yeah, there you go. And yeah, just because things change during thunderstorms or whatever, it doesn't matter because it's electrostatics is super weak. So there you go.
Very good. Very good.
Land the module.
Okay, is that okay? So now we just opened up just a discussion. So, so basically, Austin, like what? So I have an equation that can make excellent predictions. So what do you have for predicting all these things? Because I'm telling you, the electric field of the Earth, and I have a book here on the Earth's atmospheric electricity at about 31. This is about 50 kilometers or 31 miles. I mean, there's a very highly conductive layer. The electric field is falling off to, I mean, almost zero. It's like just like the millivolts per meter. I mean, it just gets really down, and the average is 8 volts per meter going up to 30 kilometers. And this is actually from one of the things you were showing on your Corona motors, right? They actually had this diagram on your Corona motor little thing. The guys that did the Corona motors drew this diagram. And I saw you using that demonstration on one of your videos on Corona motors, right? And they were basically saying the same thing that I'm saying. But see, gravity doesn't stop at 31 miles up. Gravity keeps going out. I mean, so this just doesn't work. I mean, and with lightning storms, it's even worse because you say it's a incoherent, incoherent dielectric acceleration.
Mhm.
That you says that gives you the bias of the downward acceleration, but during a thunderstorm, it reverses direction and increases 100-fold. How does that work? It doesn't.
Okay. It doesn't reverse the entire Earth's electric field. That never happens.
Wait, 7 million lightning strikes a day? That is a lot of reversals. And if you
That's what gives the Earth its negative surface charge.
If you pick up a book and understand Earth's atmospheric electricity, you would start to realize what you're saying is nonsense.
Do you think the entire Earth's electric field flips?
No, what's happening, it's a global circuit. What you have is you have the downward, like you said, the fair weather electric field, as you're saying, coming down. Then you've got like currents in the Earth, and then the lightning strike, it's putting it back. So it's a circuit going around. So in the current, the fields are going sideways here up on these upper layers. So that would mean gravity would be going sideways up here. It's always down, Austin, always down.
It's always down because there's an equipotential increase of positive potential.
Why don't we start levitating around a lightning storm?
Okay, because that's just a very temporal discharge, and the density of whatever it is that's on the ground has a buoyant force that, again, is much stronger than electrostatics. So that's what sets the up and down, but your density, the buoyant force that comes from your density, is much stronger. And again, the entire electric field of the Earth never flips. It never happens.
No, I didn't say that's the entire field. I said there's around 7 million lightning strikes a day. So that's a lot of reversals of polarity. And the point is gravity is always a very, very smooth. I mean, again, you said it varies a lot. It does vary. I agree. But it doesn't vary by more than 9.77 to 9.83 at the surface. That's
not even entirely true. It doesn't matter.
I got a source for that. Actually, it is true.
There's gravitational anomalies. There's like 7 different types of gravitational anomalies.
But I'm telling you, the acceleration of gravity is very well mapped out by geodesists. Very well mapped out.
Well, why wouldn't that work with electrostatics, though?
Again, I just told you, because the electric field is dropping off a lot more quickly than the gravitational field is. You know what the gravitational acceleration is at 30 miles up, Austin?
The gravitational acceleration?
Again, I can use
it's pretty much always the same.
I can use my equation to make accurate predictions. You don't have an equation. You don't have anything over here. See that red box, Austin?
Yeah.
You don't have anything to put in that box to make any predictions. Or if you do, let me know.
Well, for force, that says F equals. So yeah, force equals mass times acceleration.
Okay, but again, what's the acceleration? Where are you getting that from electrostatics?
That's what everything is it's literally all electrostatics.
Use Coulomb's law to derive that then if you're using electrostatics.
We could use Coulomb's law, but it doesn't matter.
That MA to Coulomb's law, and I tried that. You know what you get is nonsense. Absolute nonsense.
That's a lot of specificity you got for us there, Bryant. The thing here is, my God.
That's what Walter Lewin, when he did his presentation on electrostatics, he derived Coulomb's law. That's the equation you use for electrostatics.
I know. Yeah, it's almost exactly the same as the gravitational law, but it's just charge is different.
Give us an equation that will give us
finish that thought. Go ahead, Austin.
It's just charge that is different, but the point is that downward acceleration is just roughly agreed upon 9.8 meters per second squared, Brian. It fluctuates a little bit. It's not constant. It changes all the time, and it actually changes during thunderstorms. I've read the data. During thunderstorms, how fast something falls at the surface changes. So how does that work?
Well, show me the research. Can you give me a reference on the study that shows that, please?
Sure, yeah.
Okay, send it to me.
Yeah, I mean, I'm not going to.
I'd love to see that how gravity changes during a thunderstorm. I would love
and
to
during rainfall.
Okay, I'd love
Isn't
to
that
see
interesting though, Brian? But just I will send you all the resources.
Well, listen,
hypothetically, what would be your answer? Because this is well documented at universities.
Well, I'm not going to say anything until you show me that study because I'm skeptical.
Okay.
I know gravity cannot be shielded, Austin. I know this. So what you're saying can't be possibly true.
What can't be? You're just reifying it. Do you know what a reification fallacy is?
I want to do 1 minute back and forth so that we're not talking over each other. Are you guys okay?
I mean, I think we're fine. So we can just try to keep it both. Do you know what a reification fallacy is, Bryant?
Yeah, I do know. But again, science doesn't claim to be. We're using models to make accurate predictions. We're not trying to say that the model is the thing. We're just saying that these models of gravity that we have work, and the ones you have don't. You don't have any model. Yeah,
I do. I just replace your little g with the letter A.
Okay, but then you got to set MA equal to what's the force then? That's Coulomb's laws, electrostatics. If otherwise, is it F equals D for density? I mean, what are we going to put in there? Do we
there's electrostatic field, but
do we set density equal to MA? I mean, is that what we should put? D equals MA?
Wait, time out. You said gravity can't be shielded. You know, electrostatics can't be shielded or removed.
Yes,
it's all
provably. It's called a dielectric constant. Every material has a dielectric constant which shields electric fields.
You can't shield an electrostatic
Yes,
field.
you can. Your body
objectively cannot.
Yes, you can't. Your body has a dielectric of 50, Austin. Your body actually shields electric fields up to 50-fold.
Are you saying that we can shield electrostatics?
Electric fields, yes.
Electrostatics.
Electrostatics, if you have an electrostatics object, it's giving off an electric field. That's how it works.
There's an electrostatic field. But can you ever shield from electrostatics?
Yes, you can. You can shield electric fields.
You can't, Bryant.
Well, show me the paper that says that, please.
Okay.
I'd love to see that evidence.
You're making the positive claim that you actually can do it. So what, you use a Faraday cage? That doesn't do it. So what else are you going to use other than a Faraday cage?
Look up any electrodynamics textbook. Electric fields can provably be shielded. Provably.
You cannot eliminate the variable of electrostatics, and you can't block them. Faraday cages stop electromagnetic transfer, not electrostatics. So this is the point, man. You don't have evidence for your claim. I can tangibly manipulate my claim. That's the difference.
I gave you evidence. I gave you. There's 12 peer-reviewed studies that I gave. I didn't get one peer-reviewed study from you.
Yeah, I can give you all kinds of evidence. I'll give you, but listen, here's what I want to know. Why does the acceleration change at the surface if gravity's constant and always there? Why does it change?
It changes because of the centrifugal force. It's actually gravity doesn't change. Okay, what changes is you got to subtract the centrifugal acceleration. So the effective net force at the equator is less than the poles by about 5%, because for two reasons why. Number one, the poles the equator is about 14 miles wider, right, than the equator. And then the equator is 14 miles wider. So you're a little further from the center of the Earth, and you're spinning. So you got to subtract those two things. So it comes out to 0.05, but it's only a difference. 9.77 to 9.83, Austin. That's not a very big difference.
But you said it was constant. So the point is that it changes because electrostatics is super weak, Bryant. So the fluctuation in fluctuation in the electrostatics won't change it much because it's super weak, but it does change. And I already told you, I haven't showed you yet, that it changes during rain and thunderstorms and lightning storms, which goes to show you there's a relationship. We can manipulate the variable, make things go up or down way more or fall faster. This proves that it is objectively a variable that's relevant to all of these things. And your gravity explanation can explain clouds, it can't explain anything. It's just an idea to try to claim the Earth's a ball.
Yeah.
Good.
But let's get back to this for a second. So up here at 30 kilometers or 30 miles, you got near zero electric field, okay? But the gravitational acceleration is still 9.71. It didn't fall by very much, but your electric field's almost zero. So how in the world can that account for, again, the 9.8, 9.8, you're right. It's an average across the surface of the Earth, but it only varies from 9.77 to 9.83. But it does go down with altitude, right? So the top of Mount Everest is going to be lower. So again, this equation I gave you. I mean, it's simply, you can calculate the gravitational acceleration at any distance from the surface of the Earth. But because we live on the surface of the Earth, we're almost always dealing with 7.83. But your model has no equation that can tell us what the acceleration is. Do you agree it's a 1 over r squared law? Can you at least acknowledge that maybe it's a 1 over r squared drop off?
Well, I need to verify your r there, wouldn't I?
Well, okay, but I'm saying it is a 1 over r squared drop off provably. I mean, we can take the measurements. I mean, you can measure the acceleration going up in altitude and see that it is falling exactly by this equation right here, by the 1 over r squared.
Is your claim that there's no proportionate relationship to acceleration and then how high up you go in the electrostatic field?
Say that again. I didn't.
Are you claiming there's not a proportionate relationship to acceleration and how high you go up in the electrostatic field of the Earth?
Well, the electrostatic field of the Earth is, again, it's a very complex thing. Gravity is just straight down towards the center of the Earth.
You just keep on reifying it, though, man. I mean,
I'm not reifying it. You don't have any equation, no model, no research to substantiate your claims.
We have all the evidence ever because we know we have the atmospheric electricity. Now, gravity is just assumed to be there.
The atmospheric electricity is just using. I mean, it's tapping into the gradient of electricity, but that doesn't prove that things fall 9.8 meters per second squared.
What keeps clouds up?
Clouds, it's a very complex fluid dynamic situation where you have warm air rising and a very fine mist of water. It gets to a certain altitude, cools off, it condenses into clouds, and at some point it's going to rain and come back down. I mean,
Why?
just like well, it's basically heat, pressure. I mean, there is gravity involved because the water rains down and comes down again. I mean,
Wait, doesn't the clouds hold like millions of pounds of water? So just accounting for gravity, why wouldn't it just fall down?
Again, the clouds are spread out, and it's a very fine mist. So just like dust in the morning when the sun comes through your window, you can see the dust particles, they're floating in the air.
Mm-hmm.
I mean, gravity's still working down on them, but when you have a very, very small surface area, it's a surface to volume ratio. The air resistance gets proportionally greater as you get a smaller and smaller size because your surface to volume goes up, right? So for example, let me give you an example. You can drop an ant from like 10 feet up and it'll walk away. Why? Because the air resistance, because it's so small, it's got a lot of surface area to its small little volume. So when you have little tiny mists of water like that, they have, warm air rises, right, Austin? So hot air balloons work this way. So the warm air that rises up, then it gets to a certain altitude, it cools off, and then it kind of condenses into the clouds. But it's not like there's just like a big ocean of water up there. It's very fine mist particles that have a very high surface area to volume ratio. So they will come down. Gravity eventually brings them down. That's what we get rain, right?
All right, that was a lot. Objectively, even within your paradigm, clouds are held together with electrostatics. What happens is there's a friction. Ryan, come on.
Okay.
There's a friction that builds up inside the clouds, and it creates charge, and the charge continues to build, and then the charge within the cloud begins to like situate out, and eventually you have what's called negative charge. It's discharging going on at the bottom of the cloud, so much so that eventually you will have something like lightning happening, which is a discharge going down to seek equilibrium to the surface because there's a downward flow of electricity on the Earth. There's a downward flow. Clouds are held together with electrostatics. They're within the electrostatic field. All of the water and the ice crystals in the cloud are electrostatic. They all situate themselves based on that. That's what lightning is. It's electrostatic discharge seeking equilibrium. So we have a downward electric flow on the Earth. Electrostatics is 10 to 36 power stronger than gravity claims to be, and everything has a downward bias, and then the different forces like kinetic energy and buoyant force is stronger than that. This is just objective.
But the lightning strikes go back up though too, Austin. It goes the other way. You know, lightning bolts go up and down. They don't just go down.
Okay.
So that's it just nullifies what you just said about downward. It's not a downward acceleration then. That's because if it's going up, we don't levitate. Again, we're not levitating around thunderstorms.
You wouldn't levitate because you're so much more dense than the air. You're still going to be down. Electrostatics is very weak. It just sets the up and down. That's a ridiculous response to say that we should levitate if electrostatics was real. That doesn't make sense.
It does make sense because the voltage increases by 100-fold, Austin. So not only does it reverse direction, it's going to like 15 to 20,000 volts the other direction instead of.
You have to go by like 1 million though, Bryant. That's what you don't understand. The whole Earth's electrostatic field just sets the up and down. Your buoyant force of density is so much stronger. We do have things levitate, and we have electrostatic levitation in nature. It happens all the time. The fact that lightning goes up and down, which actually looking at slow motion, it's really crazy. Lightning is a baffling thing. Yeah, there's discharges from the surface as well, based on what charge is on the surface and what is in the clouds above that. That's what it is. It's just seeking equilibrium relative to the charge and discharge levels of the cloud and the ground. It going up and down doesn't change anything. My point is that all of it's electrostatic. Everything is, and that's way stronger than gravity.
Everything's not electrostatic.
Name one thing.
Well, first of all, you know there are 4 forces in nature, not just electromagnetism, right?
Can you name one thing that's not electrostatic?
Gravity. Well, it's part of everything, but so is gravity, and so is the nuclear force, so is the weak. And then you got the electromagnetic force, which you're referencing, but you're ignoring for some reason the other 3 forces.
No, I'm not. They're all electric.
They're all electric. The nuclear
Name one of them that's not. We're not counting gravity because gravity isn't actually real.
The nuclear force is electric?
Yeah.
Okay, show me evidence for that. Because
it
literally does the opposite. It actually holds like charges together. Do you know that
you didn't know that was electric?
Do you know that like charges repel? Do you know that?
Yeah, but incoherent charges always attract. So you need polarization. You need polarization to have attraction and repulsion. But listen, even the neutron, the nuclear forces, all that, they have elementary charge, something that's called elementary charge. They still have a charge on the most fundamental level. That's the only way that you could have any of this stuff held together inside the atomic theory. The protons and the neutrons, you say they cancel out. You have bosons and all these different, particle physics, pseudoscientific terms. It's all charge. Everything has a charge. It's all electric. Everything is. Okay, so that's my point.
Charges repel. I've done many little pith ball experiments when I used to teach physics. Those little balls will repel each other. They don't come together, Austin. You're just talking nonsense.
Incoherent.
What
Electrostatic acceleration is always attractive. You have to have polarization to get repulsion.
Where does that come from? It doesn't. I mean, what can you show me a research study that references incoherent dielectric acceleration?
Well, it'd have to be something from like electrical field theory, like decades and decades ago, before the pseudoscientific derailment of modern science because of the devotion to heliocentrism. But yeah.
Austin, look at the world around us. We are advancing in technology. We're not going back in the dark ages. So don't say that the science of the 1800s is somehow better than the science of today.
Actually, it is because of the Michelson-Morley, and then everyone went the wrong way. We don't have to change the subject, but the point is they threw out the background medium for electrical field theory, and then they ran over here towards trying to explain the Earth as a ball. So that's what happened. So yeah. I don't agree with subatomic particle pseudoscience. It doesn't work. Particle physics has been debunked. It claims electrostatics is the exchange of virtual photons because the math doesn't work. So objectively, you guys are falling apart as time goes.
We're not falling apart. Again, you're not understanding a scientific law and what a scientific theory mean. They work in their domains of application. If that didn't work, we wouldn't have, computers, quantum mechanics is the basis of the computer you're looking at, of lasers and cell phones. So you can't say that these things are disproven when you have technology all around you that is actually using those things.
Wait, you think virtual photons are real?
Virtual photons are part of a mathematical. You know the difference between a mathematical model is versus
reality? Yeah, I do.
Again, it makes predictions that we can use to make things and to do wonderful things in this world and this universe. So a mathematical model is about gathering evidence from observations, creating a model that can be used to make predictions and to create a theory that can then, we can apply this in engineering and do a lot of wonderful things with.
Yeah, I don't dispute the just to wrap this up, we can maybe move on. I don't dispute the conventions are valuable, Bryant. It's the fact that they're not reality. They're wrong. Particle physics made a prediction for magnetism and electrostatics, and it was debunked, and they had to invoke virtual photons. Everything's electrostatic. That's 10 to the 36 power, stronger than gravity even claims to be. You can't eliminate the variable. We have an electric gradient on the Earth. You have to have two Gaussian surfaces to have the equipotential increase in electricity. So the globe can't even explain how we have equipotential increase of electricity, and it has a downward flow on the Earth, and it's much stronger than gravity even claims to be until you get onto the planetary scale, and even Walter Lewin from MIT will tell you that.
Yeah, again, this book right here actually explains the electric field and how it's created through a very complex interaction between the sun, the magnetosphere, and the atmosphere. So it actually, we can explain it, and it's not downward, an incoherent dielectric acceleration. Not once is it. I've never seen that anywhere in any book. And again, if you don't have any studies that can actually verify what you're saying, and if you don't have an equation that can actually make any predictions, which you guys don't, I mean, seriously.
I just told you we do. We have the same equation. We just put A there instead of little g. Why do you keep walking past that and saying it anyway?
Because that equation uses on the other side of it Newtonian's law of gravity. So where is your, again, you said F equals ma equals what's the force? So ma equals Coulomb's law equals gravitation equals kx for the, for springs.
There's electrostatic field. Yeah.
So every force it's equal to ma. So what are you using? What equation are we going to use to be able to make these predictions?
What predictions?
Because you basically got to use gravitation. The only way you can is to use the gravitational equation. You got to
no. You're not understanding that the gravitational constant is just the downward acceleration agreed upon average. You put little g there. It's just the effect. Little g is not gravity. It's downward acceleration. It doesn't prove the cause of downward acceleration. It's non sequitur. That equation is not exclusive to you, nor does it give your point any type of value in this discussion.
It actually does, Austin, because little g is only, we only measured empirically at the surface. We can predict with this equation what g will be, 100 miles up in the air.
And it's wrong all the time.
How show me evidence for that claim, please.
Okay, I'll show you the gravitational anomalous chart, and it's starting at the surface all the way up.
Here's the problem. Where is your evidence? If you can't make a prediction and to get these numbers that we all can observe and see,
we don't see them. They fluctuate greatly. That's not what happens.
You've got nothing. You're just saying words. That's all it is words.
Objectively, it isn't exactly as predicted by gravity all over the Earth. There's all kinds of anomalies.
Again,
and if they were to account for the electrostatic field and all the variables based on electrostatic induction, they would get much more accurate readings, but they don't do that. So we may have exhausted it. It's been an hour if you want to move on a spin.
Okay, I know, but show me some evidence. I haven't seen any. I'm still waiting, and I've watched a lot of your debates. I haven't seen you provide any solid, tangible evidence for this claim.
We can manipulate the independent. We can manipulate the independent variable of electrostatics. So this is how science works, Bryant, right? This is how science works. You have a naturally occurring observable phenomena that you want to figure out. That's how natural science works. You want to study that effect and see, can I figure out what causes this? It's a cause and effect relationship test that you then propose called a hypothesis. So it's like things go up or down, okay? Things have vectors, directionality. We see things go down. That's our naturally occurring observable phenomena. Now we're going to presume the cause is electrostatics. So if I manipulate electrostatics, it will cause things to go up and or down. And we're going to run an experiment to test that. And when we manipulate electrostatics, like in a Van de Graaff generator, things will go up. They will weigh more. They will accelerate faster. You can make things go up and down manipulating electrostatics, and you can replicate that equipotential increase with two Gaussian surfaces like we have on the Earth. This is actual science. Gravity has none of that.
I know that's just electrostatics, so that's not gravity. I mean, I used to teach physics. I used to use an Van de Graaff generator. You could just get a wool sweater and a balloon, and you could add. You don't even need to get those Van de Graaff generators. I mean.
I know, you're right. You can do it with all kinds of... Now, can you do the same thing and give us scientific, experimentally valid, verifiable evidence that gravity's real?
But do you have an equation that can make any predictions, a model that can make any predictions at all? I mean, seriously, just one prediction. I can
just call it the electric constant. I can just call it the electric constant acceleration, put the letter A there.
I mean, can you solve this with your model? If a ball drops from a 10 meter on the ledge, what's the object's velocity before it's the ground using your model? I mean, I'd love to see you use your model to solve this little problem. It's a very simple problem. with Newton's kinematics and gravity. But if you can't solve a simple problem like this, you absolutely have no model at all, because you got to be able to make a prediction, Austin. Otherwise, you've got nothing.
Okay, but we can make all kinds of predictions with electrostatics, because all you're doing to do yours, all you're doing for yours is factoring in an agreed upon average of downward acceleration.
It's much more than that. And
What is it?
Have you even read a book on statics and dynamics? And do you even know? I've taken these classes in Georgia Tech. Okay.
Okay.
It's much more than just substituting. I mean, G is not the only thing that goes into this. It's actual gravity, is also mass times that. And then you got to deal with torques and all kinds of other things.
Yeah.
But it's not just G. You can't just say, oh, that's RG, and you're just you're rebranding your gravity into electrostatics.
You think that you have exclusive acknowledgement of the conceptual quantification of matter that we call mass, which is resistance to acceleration? You're saying that, but we're actually now can't use the idea of mass because you believe the Earth's a ball? That makes no sense whatsoever. You don't have any type of exclusivity with the idea of mass. It's just a concept, and it has many different definitions.
So if I step on a scale, then what's going on? I mean, I know in my Newtonian model what's going on. So if I step on the scale and see 150 pounds or whatever, 100 kilograms.
Yeah.
What in your model? What does that mean? I mean, it's please tell me, what is weight?
So we could just say weight equals ma.
Okay, but again, weight equals ma is not good enough, because
Why not?
you have to, again, because again, if you understand physics, force equals ma. You always have some kind of force on the other side of ma. Like I said, electrostatic force is Coulomb's law. Gravitational force is Newton's law. The spring. If you're dealing with springs, you got minus kx. All of those, you need some force equation, Austin, or you got nothing.
Weight equals mg is what you believe. Okay. Little g is 9.8 meters per second squared. That's how you determine weight. That's an agreed upon average of downward acceleration that isn't completely constant. We also get to use that number. Weight is actually specific to many things, including vector, coherency, medium, location. It changes based on location on the Earth. There are all kinds of variables that should be in that equation. It's downward pressure over a certain area. It is objectively electrostatic, and it's in an electrostatic field. I could make something float off the scale with electrostatics, Bryant.
Okay, but you got to add charge to it into a small little thing. I mean, I used to do that too. That's not proving anything.
Are you saying there wasn't charge there before I added it?
When you stand on a scale, that's mg. So that's mass attracting mass. You do get that, right? When you're on. So in your model, if you are acknowledging mass, then you're basically admitting that mass is attracting mass.
No, your model doesn't even claim mass attracts mass anymore. So, but it doesn't matter. Like it. No. Gravity is no longer considered an intrinsic property of matter for over a century. It's the bending and warping of space-time.
Did you listen to what I said about what a law is?
Yeah, your law is nothing more than an equation describing the effect of downward acceleration.
It works. Like I said, the world around you is filled with examples that it works.
Yeah, and we can use it too. It's an agreed upon average for the 10th time.
That's gravity. You got to, again, you don't have a force equation, Austin. So
we'll let the audience decide.
Okay.
Let's go to the next one.
Yeah.
Let's go on to the next one. Okay. So
who's going first this time?
Let's go to rotation.
He can go first.
Okay, we doing 10 minutes?
Okay.
Yeah.
Hold on. Just give me a second to get the load up.
Oops, that's 5. Okay, 10 when you're ready.
Okay, I'm ready.
So the subject on this one, we're moving on to spin of the Earth.
Yeah.
Yes.
And you have a hard stop at 8, right?
Yeah.
Okay. Or
your time. Yeah, that's right. So,
okay, go ahead.
We'll make this kind of fast. Okay, so go ahead and start.
Yep.
I'm sorry, I'm getting some notifications here. Hold on. Okay, can you share my screen?
Yes.
Share.
I don't know, Austin. Why come mine says remove only when I go down there? I don't know how you.
I don't know. You should have admin.
Yeah, it just says remove is my only option for some reason. All right, we're good. We're fine. Go ahead. Who's? Oh no, Brian wants his up.
Yeah, I want mine up. If you can.
Oh, my bad.
Reset the clock there. I mean,
You don't want to use Walter Lewin, bro?
I love Walter Lewin. In fact, again, you got to watch his gravity lectures because they're great.
Mm-hmm.
Seriously,
Okay,
I mean, they're really good.
Clock start.
Okay, so now we're going to talk about the Earth's rotation, and I just want to provide many different ways that we can see that the Earth does rotate. So the first one I want to briefly go over is sunrise and sunsets and lighting. Then I want to look at counter-rotating star fields, equatorial mountain telescopes, we'll just mention really quickly. The centrifugal force itself is great evidence that the Earth is rotating. The ᴏᴏ effect on east to west flights is a good evidence that the Earth is rotating. And then, of course, we got gyroscopes. We got optical gyroscopes, mechanical gyroscopes, the Foucault pendulum, long-range ballistics. And so let's just start with sunrise and sunset here. So I really like this little proof. So I just want you to watch this little animation. You can see the mountain here is lighting up from the top down. This is looking west at sunrise. So sun's rising, you're looking west the opposite direction. Now this is sunset on Mount Everest. So you can see the opposite. The last thing to stay lit is the top of the mountain. So now if you look at the way that the sun works on a flat Earth, the spotlight sun, any light source, even a laser, has divergence. It's going to spread out. So the bottom of those mountains should be lighting up first on a flat Earth. And at nighttime when the sun sets, the last thing that it's the opposite direction too. The bottom should be lit up last. But it's just the opposite, which is perfectly explainable by the rotating Earth. So you can see the light rays are coming in here. And then as the Earth rotates around, the top of the mountain is going to come up first and get those light rays. And if you just play around with this and kind of think about it, you'll see this is a really great proof. The second one is counter-rotating star trails. So this is, I call this the insurmountable failure of flat Earth, to try to explain how the northern and southern hemisphere can have not only two different star trails that are rotating in different directions, but two totally different north stars. But this works perfectly on a globe. And I really like the equatorial, when you look at these star trails on the equator, because you can actually see these counter-rotating fields going in different directions at the equator, you know, or the ecliptic. I mean, the equatorial. So to me, this is just a great proof that we have two poles. And you got in the southern hemisphere, again, down is down. So when we look south, we're looking down towards these stars. On the flat Earth, you're looking towards the ice wall. So it just doesn't make any sense. So in the northern hemisphere, everybody's seeing just Polaris. And below, you can see it just south of the equator, you can still see Polaris just based on, but when you get a far enough latitude down, you just can't see it. But the point is that we got two different rotating fields that's perfectly explainable by a rotating Earth. Okay, so the next thing is kind of related to this is equatorial telescope mounts. And I believe there was a challenge to one of the flat Earth debunkers had to give a challenge to flat earthers to explain or model how equatorial telescopes could work on a flat Earth. Because again, these telescopes stay mounted in one direction and they rotate, and so that way you can stay locked on one star. So they don't need to be moving. Now you can see over here on a flat Earth, you would have to constantly be moving and adjusting your telescope to be able to see that, say, the North Star, for example, where on a globe, it makes perfect sense that equatorial telescopes work just fine. The next thing I want to talk about is the centrifugal force. So this also is very conclusive evidence that we are on a spinning sphere. So the centrifugal force is the force due to the rotation of the Earth. And you can actually measure that things weigh less at the equator than the North Pole. This is why in the old days you could only buy gold on a counterbalance because they know otherwise you could buy gold at the equator and sell it up in Alaska and make money. So it's a well-known fact that things do weigh less at the equator than the poles. And actually, as you go up in latitude, and again, this doesn't make any sense on a flat Earth why things would weigh less if it's just all flat. Now, related to that is the ᴏᴏ effect, which is related. It's a component of the Coriolis effect in the up-down direction. So basically, it's related to centrifugal force in the sense that if you're on a plane flying in the same direction as the Earth, and again, the Earth and the atmosphere are all rotating together, but the plane relative to the Earth atmosphere frame is going to be going in a little extra fast. So that's going to create a little more centrifugal. And again, you can actually weigh this, and it's the opposite is the effect when you go against the rotation of the Earth. Again, Earth and atmosphere rotating together, but the plane traveling relative to the Earth, to rotating Earth atmosphere, is going a little faster. So you're going to get a little bit more of that. It's similar to just extra centrifugal boost there. And you can actually weigh. This is Wolfie 6020, who is a pilot, and he did an experiment where he was flying from east to west, and he did see that things were weighing more than going from west to east. So when you're going with the rotation, you're going faster, you're getting more centrifugal, things will weigh less. Against the rotation, again, really, really great evidence for a spherical spinning Earth. The ring laser gyroscope, I'm getting a little low on time here, so I think a lot of people in the flat Earth community know enough about this, but it's worth mentioning that these are just so incredibly accurate, and they're in the inertial systems of ships, planes, helicopters, the ISS, submarines, missiles, satellites. So incredibly, so I kind of want to talk about some really good studies, some peer-reviewed studies using, again, these are much bigger and even more accurate than small little ring laser gyroscopes. So this is a great study showing the Chandler wobble. So what the Earth actually not only rotates, but it has little wobbles. There's an annual wobble, a Chandler wobble, and they've even recently detected a daily wobble that's so small that we almost know where the spinning axis is to the centimeter. Some of these studies, so these they're basically just really big ring laser gyroscopes that are incredibly accurate. And in this particular study here, they were able to directly measure the rotating Earth and the Chandler wobble, which is named after the guy who discovered it. Now, this is another peer-reviewed study that showed not only the Chandler wobble here, again, using another a very large ring laser type of gyroscope, and they had one in Germany and New Zealand. So they kind of combined their data to get even more accurate answers. And what's really, to me, what I love about this study is you can even see some of the daily. So this big sweep here is the Chandler wobble, and the little tiny sweeps here are some of the daily fluctuations. So the Earth, again, not only are we not stationary, we're spinning, but the wobbles are very accurately measured by these very, very sensitive ring laser gyroscopes that are very large scale, that are going to be much more accurate than the small ones that I know your community has had access to. So this is another one, kind of similar things. The nice thing about this study, again, peer-reviewed study, showing not only the measuring accurately the rotation of the Earth, but also seismic activity. So they're finding that ring laser gyroscopes can be very useful for geologists in detecting seismic behavior. Now, what's really cool is these gyroscopes, these ring laser gyroscopes, are now getting to the point where the technology is getting to the point where they can put them in chips or chip scale, and this means probably in the not so distant future we'll be able to have little ring laser gyroscopes in our iPhone or in different types of smaller technology. So it's really cool technology. Now, moving on to actually mechanical gyroscopes, this right here is a marine gyro compass. These have been used for a long time, and people that are like the Marines and the Navy, and where you have to be able to find true north as your life depends on it. They're incredibly accurate. They don't have biases. They're built in such a way where you're getting the absolute true north spin of the Earth. Again, excellent evidence that we live on a spinning sphere. Now, I love this study. I didn't want to put in a Foucault pendulum thing because I know you guys have your whole gimbal type of arguments. But the cool thing about this study is this is a plastic ball, no gimbals, that's in like a levitating field. And it's just basically measuring the rotation of the Earth very sensitively. They actually got very, very good results, very accurate results without using no attachments here, just a free spinning. And you can read the study because we just don't have the time to get into these studies. Now, this is something kind of similar. This is detecting the rotation of the Earth using a superfluid. So again, this is not these are mechanical in the sense that they're fluids and physical things moving. And this was able to also very accurately measure the Earth's rotation rate, to be precise, within 0.5%. So just an interesting, creative way. So it's really cool that we can, in all these different ways, measure the rotation of the Earth. And also, I know you guys said that you've interviewed people that, but just in closing here, the Coriolis force is actually very real. I've got a couple long-range ballistic books. I'm running out of time, but there's chapters on the Coriolis force. So these are people that actually teach long-range ballistics, and they absolutely teach Coriolis. It's a real thing, and we didn't have time my time is up, so we didn't have time to get into that.
Austin,
So-
you got 10 minutes.
All right. So, yeah, here are the wind patterns on a flat Earth. Look, it actually makes sense. I don't know how the wind patterns would somehow help the globe. That doesn't make any sense to me. So anyway, yeah, ring laser gyros, they detect 15 degrees per hour, relative to latitude, of course, the cosine. So this all started with Michelson-Gale-Pearson, right? That's what that is. It's called the Sagnac effect. Sagnac said it was the vortex in the ether. So they did Michelson-Morley trying to detect the orbit, and they did not detect the orbit. Then they did Michelson-Gale-Pearson using the same methodology, and they matched the predictions of the sidereal rotation within 98% accuracy. So if you combine Michelson-Morley and Michelson-Gale-Pearson, what it actually shows you is that the only viable explanation is that the Earth is not spinning, and we're detecting the motion of the sky around the Earth. Secondly, you brought up planes flying over the Earth spinning. Any flight that goes north to south on a spinning ball would have to account for the Earth spinning underneath it. You know, prominent people, even Neil deGrasse Tyson, which I know you say you don't agree with everything he says, but he said that actually this guy kicked a field goal and won the football game because the Earth spun underneath the football as it was north to south. Now, the anti-flat earthers walked that back and they say that isn't the case for whatever reason, but then they turn around and they claim that there's a spinning bullet above the Earth spins under the bullet. So they are claiming that actually. You have to have an inertial and accelerative frame to get that effect. Then they claim that the atmosphere moves in lockstep with the atmosphere, contradictory to that with the Earth. The atmosphere moves in lockstep with the Earth, and contradictory to the idea that you have an inertial and accelerative frame to have the Coriolis effect. Anyway, it obviously cannot move in lockstep with the Earth because that would violate the law of conservation of energy. As you increase above the Earth, you would have to have a proportionate increase in energy because you would need a proportionate increase in speed, because obviously to travel a greater distance in the same amount of time would need you to travel faster. So anyway, that right there is a problem. You'd have to introduce a mechanism to introduce additional energy to make it go faster around the Earth. Secondly, they claim something called super rotation, where the top of the atmosphere actually moves faster than the Earth. You would need another mechanism to introduce energy, or it would violate the law of conservation of energy momentum. Anyway, the plane flies over the Earth, and it does not bank to the left when it's flying from north to south. It doesn't bank over and then accelerate forward to somehow catch up to the Earth spinning underneath it. It just adjusts left and right based on the wind. Now, no autopilot or any manual pilot flights ever have accounted for Coriolis with a consistent update. So they say, oh, well, it's not that much. And the spin of the Earth is accounted for just naturally as you update for the wind. That makes no sense, though. If you're going straight and then the wind moves you over to the right, but the Earth's spinning to the left, as the plane adjusts back to go straight to the point it originally was, it would have to additionally adjust to get to the location that would be catching up with the Earth. So if you flew 5.5 hours without adjusting for Coriolis, you'd be like 3,000 kilometers off of your path. And no globe earther proponent ever addresses this at all. There is no answer. So in addition to that, you claim you didn't want to talk about pendulums, but then you brought up mechanical gyros, which actually don't pick up the spin of the Earth, hilariously enough, and are super inconsistent with the claims that they do. And that doesn't work. It would have to always pick up the spin of the Earth. All mechanical gyros would pick up the spin of the Earth if it was the Earth rotating. Once again, it shows you that the ring laser gyro has an effect detecting some type of motion and actually points to a background medium. But anyway, so Einstein himself said, which I'll actually drop this here on the screen. Einstein himself said that if there was, in a letter he wrote to Ernst Mach in 1913, he said that if the sky was moving around the Earth, then you would have a translation of motion, and then you would have Coriolis and centrifugal effects on a stationary Earth that was central. Because if the sky was moving around the Earth, it would translate the motion. You would have centrifugal and Coriolis effects, and so it would drag the pendulum around. And that doesn't prove one way or the other. And he had to actually incorporate this principle for the Eddington experiment, where they claim they saw the star go around the sun in the eclipse. Now, what only thing I've ever gotten back from that is he didn't say that. Well, yeah, he did. I'll show the letter right here. But anyway, so even according to relativity, that's not an appeal to authority or anything. I'm telling you what relativity says, the person that made it. He says that if the Earth was stationary and the sky was moving around it, you would get centrifugal and Coriolis effects. So even if that was true in your story about pendulums and all this stuff, even though the truth is that mechanical gyros don't detect anything, it would just be detecting that the Earth is stationary and the sky moves around it. So actually all evidence with all the gyros, because the mechanical gyro does not pick up a drift. So and that doesn't prove anything. it would have to always pick up the drift of the Earth, but it doesn't. Mechanical gyros, no. Ring laser gyro, Sagneck effect, detects the sidereal rotation with a 98% accuracy, but using the same interferometry methodology, it doesn't detect the orbit, 30 kilometers a second around the sun. So that doesn't help the Earth spinning. That shows that it doesn't spin. That shows that it's stationary. And then you have like the pendulum that people bring up. Even Einstein himself would tell you that if the sky was moving around the Earth, you would drag the pendulum around. There's a translation of motion. I'm actually going to share that right now. Here we go. Okay, that'll work. So yeah, here you go. Here's the letter he wrote. If one accelerates a heavy shell of matter S, then a mass enclosed by that shell experiences an accelerative force. If one rotates the shell relative to the fixed stars about an axis going through its center, a Coriolis force arises in the interior of the shell. That is, the plane of a Foucault pendulum is dragged around. So this is him just point blank, and let me bring it back here. In this letter, he just point blank says. So this is him writing Ernst Mach. High appreciated, dear colleague. These days you have received. You may have received my new work about relativity and gravitation, which has been finished after endless struggle and torturous doubt. Next year at the solar eclipse, we will see if the light rays of the sun are being curved. In other words, the fundamental underlying assumption of the equivalence of acceleration in the frame of reference on the one hand and gravity field on the other really applies. Your happy investigation on the foundations of mechanics, Planck's unjustified criticism notwithstanding, will receive brilliant confirmation. For it necessarily turns out that inertia originates in a kind of interaction between bodies, quite in the sense of your considerations of Newton's Pell experiment. The first consequent is on page 6 of my paper. So this is him talking about how, like, literally in his paper, he had to incorporate the idea that if the sky was spinning around the Earth, that let me switch back over, that it would actually translate the motion over. So there's no evidence for the Earth spinning whatsoever. And so then the difference in weight distribution doesn't prove anything. For one, again, this actually debunks everything that you said. Within relativity itself, relativistic application says if the sky's moving around the Earth, you get the same effects and that they're identical. So weight distribution also fluctuates. And again, if there is some type of spin over top of a stationary Earth, there'd be a translation of motion. So wherever you are within that vortex field would actually have a direct effect, which is what we observe. And if we actually take our ring laser gyro and we go to a higher altitude, but we maintain latitude, we can get over a degree to degree and a half variance. Now, if the Earth is spinning, causing the gyroscope to detect the Earth's axial rotation, it cannot change at the same latitude. It has to be exactly the same at the same latitude, no matter what altitude or elevation you go. But we actually did this, and when we maintained latitude but went to a higher altitude, it changed. What that shows is you're actually detecting the motion of something above the Earth, not the Earth itself. So all the evidence that you invoked actually shows that the Earth is stationary. Of course, that's why you have to assume it's stationary to fly planes, assume it's stationary to fly helicopters, or shoot ballistic missiles. Everything that we do assumes that the Earth is stationary. You brought up the equatorial mount. The equatorial mount tracks the motion of the stars in the sky, and effectively then it just points at the ground, assuming that it's going to come back around a ball. So just assuming how to interpret the equatorial mount doesn't mean anything. And I can't believe I always hear people saying that. It blows my mind. So what I want to do for the final 2 minutes is I'm going to read some of this stuff. This is the truth of the matter, the bigger picture. The idea that the Earth is spinning and revolving around the sun is a philosophical determination. Like I just now showed you Einstein saying, oh, we can't actually prove it. It would be the same either way. If the sky is moving, then it would have a translation of motion. Einstein also said, I've come to the conclusion there's no optical experiment that could ever show the motion of the Earth. He was talking about in context of Michelson-Morley and using interferometry. He goes on later to say there's no terrestrial experiment that could ever prove the motion of the Earth. These are two different quotes. Actually, that quote is cited by Stephen Hawking in 2007, saying, I've come to the conclusion, of course, agreeing with him, there is nothing you can do on the Earth to prove that the Earth is spinning. Yet we have people running around defending the globe in 2022, claiming that it's been proven with all the stuff on the Earth since 1851. So here's Edwin Hubble giving you a little taste of it. He said, this is a philosophy. Such a condition, he's talking about the Earth being in the center, such a condition would imply that we would occupy a unique position in the universe, analogous in a sense to the ancient conception of a central Earth. This hypothesis cannot be disproved, but it is unwelcome. It would only be accepted as a last resort in order to save the phenomena. Therefore, we disregard this possibility. The unwelcome position of a favored location must be avoided at all costs. Such a favored position is intolerable. Therefore, in order to restore homogeneity and to escape the horror of a unique position, we must compensate for spatial curvature. There seems to be no other escape. So in conclusion, the truth is that all of the top tier astronomers, astrophysicists that brought us the current globe Earth model, although it's actually in shambles, they tell you it's a philosophical decision of the Copernican principle because they want to believe the Earth can't be in a special, unique position. And so you can't prove that the Earth is spinning because if the sky was moving around the Earth, we get all these same effects. But they want to believe that it is, in fact, not stationary because it would mean that it's special. So it's philosophy, also a religion, known as religion.
Okay, 5 minutes.
Yeah.
Yep. Whenever you're ready, go ahead.
Okay. You see, I'll let you know I need to share my screen. So sure. I just want to say something about ᴄᴏᴛᴇᴜ and ᴄᴏᴛᴇᴜ. Hold on. So basically, the ᴄᴏᴛᴇᴜ experiment, the Earth and the ether are stationary according to ᴄᴏᴛᴇᴜ. But then the ether cannot be simultaneously, like you say, moving according to ᴄᴏᴛᴇᴜ. I mean, you just can't have both. In fact, I read a book that went through all these ether studies, and there's like 3 different types that were talked about. Ether drag, which is where the ether is going with the Earth. Then you have just the universal ether where everything is stationary. And then you have the Lorentz ether. And when you go through all of these different studies and then you create like a chart, some of them, ᴄᴏᴛᴇᴜ, correct. It does allow for a stationary Earth and a stationary ether across the universe. But then the ᴄᴏᴛᴇᴜ totally contradicts that. And it says that there's a spinning ether spinning. So, I mean, you can't have it both ways. I mean, the two contradict each other. And there's many more studies like that, too. And then you got stellar aberration, other things that make it very clear that we're moving. And I mean, there's, again, I didn't get into all the other evidences of that we're moving. But so, again, these ether studies, ether was disproven or shown not to be needed at all, unless you just want to say everything is ether. And then you can just use the word everything is God if you want. But these actual ether as the medium for light to travel, has been very soundly debunked now for, about a century. And again, the early studies, even if one study didn't, when you put them all together, guess what? Only special relativity came across as green checks across the board through all those studies. All the other studies with ether drag, with universal ether, stationary ether, and the Lorentz ether, some studies confirmed them, some studies didn't. When you put it all together, it pretty much debunked the idea of ether. So there's just been an outdated model, and you're not going to find, I mean, you may find some, geocentrists that might have some papers on ether, but certainly, the peer-reviewed studies are going to be sparse, that are going to be saying that there's an ether, again, because we got such overwhelming evidence that it doesn't exist, at least in the way that it was originally defined. So, let's see. I mean, you mentioned, I just want to bring that too, because you talk about planes, if you go from north to south, and actually airplanes do account for that. Just wanted to, I forget where.
You want your screen up?
Just a second. I'm just trying to find it. I wasn't, because I did some of the calculations for this. It's down here. Where did I put that? Okay, here we go. Actually, I forgot I had it in my slides. Yeah, can you share my screen?
Yep.
So, you actually can do the calculations for the bank angles and how much thrust is needed to actually, because you're right. If you took off from the North Pole and you flew to the equator, remember now you're traveling like about 6,000 miles. So it's a very gradual, you do have to compensate for Coriolis. You absolutely do. And you can actually calculate the exact bank angle and the thrust needed. And it's not much. I mean, you need like the thrust needed to compensate Coriolis is only 0.0002%. And again, these are actual equations that are used with airplanes and are very, very accurate. And the bank angle is like 0.15 degrees. And the point is that the Coriolis effect, it's not that the Earth is moving out from under. That's incorrect. whoever said that, if Neil deGrasse said it, it's wrong. What the Coriolis says is that when you shoot a ballistic, you have that a greater speed at the equator than when you go north. So it's going to deflect to the right because the speed is slower at that higher latitude. So it's not that the Earth is rotating out from under you. It's that it just has more momentum at the equator. So the speed, so that's why it drifts off to the right. So that whoever said that's wrong. It doesn't. Even this book says that's a common mistake to think that the Earth rotates out from under. It's not true. Anyway, that's what I wanted to say is that you actually can calculate the bank angle needed and the amount of thrust needed to go north to south. And it is absolutely factored into airplanes. Absolutely.
Okay.
Whoa. My bad. All right, yeah, we're good.
Good.
Oh, I thought you were already starting it. It doesn't matter. So, yeah, they objectively don't do such a thing, bro. Autopilot does not account for Coriolis. And anyone that flies the plane and then goes manual would have to know that. Everyone that flies planes, everyone that knows anything about autopilot or has read the documents that engineer them or the documents that used to engineer them, they don't account for Coriolis. That's just objectively wrong. They do not do that. What they do is they account for wind. Okay. And they claim that the wind is so much stronger than the Earth's spin that you don't have to account for it, but that's wrong. We fly that plane like the Earth is stationary. Like I just now had a conversation with the pilot the other day, right? I have it recorded. Yeah, I'm like, oh, you fly the plane like it's flat and stationary. Of course, they do not update for Coriolis. No pilot ever would tell you that they're accounting for the Earth spinning. That's not how it works. You have bullet spin with bullets itself, like barrel spin, which is much stronger than Coriolis even claims to be. You have to account for wind, much stronger than Coriolis even claims to be. I don't care what they say in the book. I've talked to many people that shoot in real life. You don't account for that. You account for the wind. As for the Michelson-Morley, you said that Michelson-Morley show you can't have it both ways, stationary and moving ether, I guess is what you're saying. For one, Michelson-Morley did detect a phase shift. It did detect one. It was just 1/6 the predicted value of the Earth revolving around the sun. And in fact, it's been done dozens of times, even by the Air Force in 1987. And it still showed that there is a phase shift every single time. Then we went and did Michelson-Gell, and it shows sidereal rotation. It matches that prediction by 98% every single time. And that's because our 15 degree per hour convention that we use for time is actually just a generalized accepted average, basically, or an agreed upon convention. It changes a little bit, which is why it fluctuates from 98% to 100% accuracy. We just use that convention for time. So it matches the prediction for sidereal rotation perfectly, and it does detect a phase shift. So the only thing Michelson-Morley did was show that the ether's not stationary. And so those work perfectly together. The ether slightly drifts over top of the Earth. Okay. And this explains all the phenomena. And again, you kind of waltz past it, but I'm going to really drive this home for the last 3 minutes. Einstein, Hubble, Hawking, Arthur Eddington, you name them, Wolfgang Pauli, they all explain you can't prove that the Earth is moving from the Earth. You cannot, including stellar aberration. And they will tell you point blank that they can create a model for you that explains alleged parallax, which doesn't actually happen, retrograde motion, stellar aberration, all in a geocentric model with the Earth stationary. And you cannot prove that it's spinning or revolving on the Earth itself. It's impossible. Stephen Hawking in 2007 explained it, quoting Einstein from his writings in Special and General Theory of Relativity, his paper on the combined two theories, explaining that you cannot prove that the Earth is spinning. They choose to believe in the Copernican principle because they have a religion. That triggers people because they think they hate religion. They hate God oftentimes. But that is a religion. It's a belief system built upon the doctrine of men, void of empirical, verifiable evidence, and in fact, contrary and antithetical to the actual evidence. Despite what the evidence says, I just now read him point blank say it can never be disproven. We disregard that possibility because of the horror of a special and unique position. Right? And I have plenty of quotes here from geocentrists or heliocentrists explaining you can never prove it. You can't prove that the Earth is or that the Earth is not stationary. But we don't want to believe that because that would mean the Earth is special. So then what do? We go look out at the background distribution, the energy coming away from the Earth. It shows the Earth's in the center. So what do? They call it the axis of evil. And then they come up with a new idea. Well, it does look like we're the center, but that must mean that no matter where you are in the universe, it would look like you're in the center. Or we're just in the center. They don't want to say what it is because it has spiritual implications. It has philosophical ramifications. And that is that the earth had to be placed there. It has a special, unique position. They want to believe that there are a tiny speck of dust in an ever-expanding universe of nothingness where everything came from nothing and there's a pre-existing energy. But let's not talk about that part. Oh, lightning struck primordial soup and all this nonsense. And you know, why? That's a good question. Probably because they're scared of like moral accountability, I would guess. But this is the point. This is the problem. It's portrayed as science, and we're brainwashed and indoctrinated with this idea as if it is science and it's proven and it's not questionable. And you actually go look behind the curtain, it's philosophy, and they admit it. So that's why I gave the specific quotes, and it was walked past. It's the crux of the whole issue. There is a philosophy that leads to atheism and nihilism and materialism portrayed onto the world as if it is in fact scientific fact. You can't prove that the earth is moving. If the earth is a ball that spins, which it objectively isn't, we falsified it, everything gives us the illusion that it's stationary. And this is what all of the astronomers and astrophysicists say that gave you the current model.
Good work on the time there. All
Okay.
right, back and forth.
Right. Well, but you do know that the Meyers-Morley experiment has been done. And on my dfe.net/ether page, I've got a whole list of studies that duplicated Meyers-Morley and got better and better and better to where there was basically no fringe when you get to the really accurate studies. So you can actually show that there's no fringe shift when you do the Meyers-Morley very carefully.
You just said basically no and then none. Which one is it?
Well, it's such a small amount. I mean, you understand that experiments always have experimental error, and we're talking many decimal places on some of the best experiments. The early Meyers-Morley was, it wasn't as accurate. It just got better and better and better as the studies went on with time.
The Air Force did it in '87 and got a phase shift.
Well, just because the Air Force did it, there's peer-reviewed studies that show otherwise.
From when?
Well, again, I got them right here. We can pull some of them.
I've already looked at them. They all show a phase shift.
How much though? I mean, again,
it doesn't matter.
It does matter, because if you say 0.0, it can't be just absolute. You're looking for absolutely zero in an experiment.
That's what you're claiming is happening.
You really don't understand how science works.
I understand that you just use the instrumental error as an excuse and I have to explain it. See, special relativity was invoked to claim that the measuring apparatus physically contracted and then time slowed down, so it looks like they're the same, even though it never actually is the same. We're going to pretend that it's just instrumental error and it's always the same, and that the measuring apparatus physically shrank and you just can't tell. So is that what you believe is happening in Meyers-Morley?
The Meyers-Morley is a well laid out experimental, and it's been duplicated many times. And if you're looking for a zero, of course, science isn't going to be able to get absolute zero error. I mean, because
do you believe that in Meyers-Morley, the measuring apparatus is physically shrinking?
Well, you understand with time dilation, length contraction. I mean, when you're going fast enough, it's not going to be much, but it's that's something that that is kind of a paradox, but it does seem to happen.
So what your model claims is that there is a difference, that there is actually a phase shift, but since the measuring apparatus contracts and time expands and slows down, that it looks like there's no phase shift.
Show me your evidence or your study that validates what you just said, and that somehow
special relativity by Einstein. He gave a speech explaining it specifically. That's the whole point of special relativity.
I mean, you're just giving a bunch of quotes. You don't have any actual peer-reviewed studies to show that the Earth is stationary. I mean, where is your studies?
First of all evidence shows that the Earth is stationary. So the whole idea of relativity is to explain the theory that says, even though it always looks like the Earth is stationary, it's actually spinning, wobbling, and revolving. That's what relativity says.
I know, but I showed you 12 peer-reviewed studies. I mean, where are your studies?
I'll show you 30 different top-level astrophysicists. So if you disagree, you're disagreeing with Stephen Hawking, you're disagreeing with Albert Einstein, you're disagreeing with all the top guys, Edwin Hubble. These are the people. See, I'm not appealing to their authority. It's called a hostile witness, right? And it'd be different if you had a new theory, but you still use Einstein's theory of relativity, even though it's drastically incomplete. It's been debunked. It doesn't work on the quantum or cosmological scale. It's incompatible with quantum. It doesn't work at all, and you guys just keep it. But my point is,
no, it does. It has not been debunked within its realm of applicability. Again, you did not listen to what I talked about laws and scientific laws, how they work. Relativity never claims to work at the quantum level, or even to work necessarily to understand dark matter and dark energy.
It'd have to work on all scales if it was real.
Well, again, where's your model that does that?
Electrostatics.
Again, but it doesn't have to work on all scales to be real, because that's not how science, theories, and laws work.
That's how gravity has to work. It would have to be on all scales.
We can use science to develop models or theories that can make accurate predictions about the world we live in. And those models and those laws have domains of applicability, meaning they don't work at all scales. And so we do think that at some point there'll be a quantum theory of gravity. We just don't have it yet.
It doesn't make accurate predictions, though.
Are you kidding me? General relativity makes incredibly accurate predictions.
It's off by 95% in the universe. What are you talking about?
Okay, let's talk about that, because you really like to bring up.
It only acknowledges 5% of the universe.
The dark matter and dark. Do you understand how dark matter works around?
I understand. In 33, discovered that the galaxies only had 3% of the mass, and then it was ignored for decades, and now it's called dark matter. The idea, dark matter is the idea. You asked me how it works. I'm going to tell you how it works. It's the idea that it doesn't interact with the electromagnetic spectrum, and it's assumed to be material, but it's undefined. We don't know. It's a mathematical discrepancy with what relativity predicts.
Okay, show me a study with your that really encapsulates what you think dark matter is. I'd like to see that.
No one knows what dark matter is.
You're just saying words. Well, again, yes, I agree, but we can use dark matter in mathematical models to create using the background radiation. They can simulate that with dark matter, actually putting it into relativity. They can make very accurate models of how galaxies form, et cetera. They got supercomputers to do a lot of studies like that.
Everyone knows that relativity made a prediction of the universe, and it was off. And so if relativity is correct, there has to be something called dark matter, or relativity is wrong. That's all there is to it.
Okay. Do you know what the average density of the universe is, roughly?
I don't make pseudoscientific fairy tale claims.
Well, no, this is measurable. It's like 10 to the minus 9, grams per meter or kilograms per meter squared. It's very, very sparse. The point I'm trying to make is dark matter and dark energy are working on cosmic scales within the very fine, like for rotational, like the rotation of galaxies, right? The dark matter is probably like they think is in the halo areas of the galaxies, but it's spread out very, very thin. So if you apply dark matter to our solar system, let's say, for example, like the Pioneer, that's traveled billions of miles, they did a calculation of that if you incorporated dark matter, it would only deflect that by 1.5 meters. So
this is just all theoretical reification fallacies.
Again, there's all kinds of really good peer-reviewed papers on dark matter. And
no one peer-reviewed dark matter. No one knows what it is. It's not even defined yet.
Okay, I'll send you a whole bunch of.
Okay.
Again,
so the truth of the matter is, I don't like when people are dishonest about how awesome the model is, because the truth is, it's known that if relativity is true, it's drastically incomplete. Best case scenario, it's incompatible with the quantum scale, and it did not predict the actual observations of the cosmological scale. This is just objective. Relativity has got to be updated or replaced. Best case scenario, but I don't know why we got over to this. I want to know what your response is to the fact you can't prove that the Earth is spinning, and it's a philosophical determination.
Well, I gave you a bunch of studies. Where are your studies that it's stationary?
All evidence ever. I just explained it. I just explained that if the sky was moving, Einstein himself said that you would get the same effects.
You're cherry picking quotes. That's not studies. That's not research.
You know what cherry picking a quote is? If I take it and then I say it says something that if read in context, it says the opposite of what I'm saying. That's not what happened here. This is objectively.
You're looking specifically for quotes by these people that support your model.
I'm representing the accuracy. I'm actually accurately representing your model because you're misrepresenting it. That's what I'm doing.
Again, where is your evidence? I want to see some. You don't have an equation. You don't have a model. You can't make any predictions. I mean, our model can build the world around us. I mean,
you want to do like 2 minutes each to finish, and then we'll take the chats, because if you got to leave at 8, we're up against.
You can go first.
Brian, my one question though, I just have a question. Are we not then allowed to look at Einstein and those guys since they have a different model than us? We cannot read their books or anything.
Of course, you can read their books, but
we can't bring them up. We can't.
But they've got such a body of research that you can find quotes where they might say the opposite thing in another context somewhere else. I mean, so if you're just looking for quotes to support your model, that's just confirmation bias. You're just sort of looking for things that support what you want to see.
Yeah, that's what that's called, Bryant.
Okay.
Well, whatever it's called. I mean, I'm just saying that you're looking specifically for support for your model, but quotes are not studies. Quotes don't prove anything.
You can prove that you get a translation of motion if there's motion outside of a stationary system. It'll translate the motion to the interior of the system, and then you have centrifugal effects. You can prove it.
Okay, but again, you said a massive shell rotating. So where's this massive shell that's rotating?
There seems to be a gigantic sky. Stuff in the sky moves around the Earth.
So
That's what we observe.
Well, what is that then? Is it sky ice? I mean, what is it made
That's a good
of?
question. You want to do your 2-minute closing?
Yeah, let's do 2 minutes. You got 2 minutes whenever you're ready. If you,
Okay.
You want your screen up or no?
Oh, no, we'll just talk. So again, I just want to thank everyone for coming. It gets heated, I know, but it's still, I enjoy hanging out and talking about these topics. And I feel that with gravity and rotation, I presented actual peer-reviewed evidence that's very solid, that proves that the Earth is that gravity, again, within the scientific framework of a scientific law, the universal law of gravity is absolutely valid within its parameters. And again, it knows its limitations. It knows where it can and cannot work. Same thing with relativity. I mean, they work within their parameters. They're not meant to work at the quantum level or at some other scales. So again, the world around us is evidence that gravity absolutely, or Newton's laws and Newton's law of universal gravity absolutely still is valid, and it still works at slow speeds and low gravity, because relative to the universe, the Earth is in a very high gravitational field. I mean, it does exist here, but it's nothing like a black hole. And I did want to, can I share my screen? There is just one thing I wanted to share on that really drives this point home with Newton. Well, I didn't get to it in my presentation. Oh, hold on. Oh, here it is. So this right here, this is kind of just, and it's okay that you don't follow along here. All I want to show here is that from general relativity, you can actually recover the potential formulation of Newton's laws. And that what relativity does is just adds a correction factor to it. Even E equals mc squared does that. You know, that's just a first order approximation in the Taylor series. So the point here is that when you do like the perihelion of Mercury, you have to take into account this correction factor. But Newton's law of gravity was not proven wrong by Einstein. In fact, it's right there within relativity. It's just when space is very flat and the speeds are slow. So again, it's been fun, and we go do it again sometime.
Cool. You just go ahead and start, I guess. I think we got a ton of questions. I think we'll be fine.
Yeah.
I'll just wrap it up super
Bob,
fast.
write me on Skype how I'm supposed to find them, though. I can't find them.
So basically what we covered was that, we have scientific empirical evidence that can be verified for electrostatics. We have equipotential increase. This was never addressed, but you can't have equipotential increase of electricity like we do on the Earth unless you have two Gaussian surfaces, which means there has to be a surface above us. That's the only way that you can have it. There's a downward flow of electricity, electric downward pressure on the Earth. It's 10 to the 36 power stronger than gravity even claims to be. Little g is downward acceleration. That's for everyone. So in fact, the only thing that can be verified and proven and manipulated with science is electrostatics. And again, it's significantly stronger than gravity claims to be. They just have to claim it's something else because electrostatics wouldn't make the Earth a magic spinning ball with water spinning around it in a vacuum, spinning around other planets. And when it comes to the spin of the Earth thing, I really want this to be really for the audience to really soak this in. You were duped into thinking that the Earth is a tiny speck of dust, but it's this gigantic ball with water bending around it. The grand scheme, it's nothing and blah, blah, blah. When you actually go and research it, okay? All this stuff they claim as evidence that the Earth is spinning, it just begs the question and reifies the conceptual model over and over and over. Where you look at the gyroscope, and actually when you look into it, it shows that, well, actually the Earth is stationary, the sky moves around it. They say, oh, it's showing that the Earth moves. Then the mechanical gyro doesn't pick the Earth spinning. They just ignore it or bold-faced, like, misrepresent it and say that it does. And the truth is that all these things, even the pendulum, which is inconsistent, all this stuff is explained with the sky moving around the Earth. We live in a geocentric system. It's a stationary topographical plane. The sky moves around us. There seems to be a vortex of an energetic background where everything moves together. It's this giant, beautiful, intricate cycle as if it was crafted like a clock. It does have a special and unique position. And a lot of these atheistic quote unquote scientists that are propped up at the top, they don't like the idea that maybe the Earth was created. And so they've clung on to the Copernican principle, the idea that the Earth cannot occupy a special or unique position. And so don't let other people make your own philosophical decisions for you while simultaneously lying and brainwashing you, claiming that it's science, because it is not.
Okay. I thought it went well. Thank you, guys. Hopefully everybody enjoyed it. We can maybe do it again. Bob's going to give me a link. You have to go into your back room, Austin, to pull the super chats. We can't get in back there. We're not managers.
My back room. What do you mean?
Go.
My YouTube
studio, and then go monetization. And
yeah, you mean just read them off?
Yeah.
Okay, gotcha. All right, there's not that many. All right, Ron, I think most of them are for you, but there's not that many. Okay, so we have Bryant. We have a life-altering revelation. That was in the pre-chat. He said, "Do you have to have rotation to have gravity?"
Rotation to have gravity? No, I mean gravity. Yeah, gravity is not rotation. Gravity is mass attracting mass. But when you have orbits, you have to factor in the centrifugal. It's like a balance, right? Where you got gravitational force balance the centrifugal force. So when you write your potential equation for gravity, or for the potential of the motion of the orbit, you've got to incorporate both gravity and the rotational centrifugal force. But it's not gravity itself. Gravity is just always towards the center of mass. I mean, pulling in. So.
All right, that was Shiloh Carpenter, plain truth. All right, we're not gonna. He said, tell him, no over talking is rude or whatever. Okay, here's a question from Gender Neutral. Says, can Bryant explain the pockets of gravity on the ISS YouTube video? And number 2, how Newton's law of gravity can violate the second law of thermodynamics to hold the atmosphere of a ball against the vacuum of space?
Well, the first one, I'm not familiar with the context of the ISS, so I don't. I can answer the second one, but I mean,
yeah, fair enough.
So how? First of all, it doesn't violate the second law of thermodynamics. The second law of thermodynamics says that the entropy of the universe always increases. Now you can have the entropy of a local system decrease as long as the overall entropy of the universe increases. So with the problem with the whole atmosphere next to a vacuum thing is that, first of all, the gradient, there really is no pure vacuum. There's always particles in space. So there's never a zero vacuum environment. You're going down from a gradient that gets less and less and less and less, and then it just stays less and less and less, and et cetera. And there is a difference between atmospheric pressure and gas pressure. And sometimes flat earth enthusiasts make that confusion. They think that because gas pressure is the pressure of gas against a container, where atmospheric pressure is specifically the pressure of gravity pushing the atmosphere down on the surface of the earth. So it's defined differently. And I know you guys always bring that topic up, but it's very well explainable by gravity. In fact, the gradient is so specific that meteorologists and certain people that are into weather science know they don't even need to know what the altitude is. If they know what the pressure is at a certain altitude, they almost automatically know what the altitude is, because it's very, very precise gradient. And you only get a very precise gradient like that when you have a downward acting force. So the force itself, Anyway,
there's an electric gradient. We can move on. So Bjorn Magnusson, sorry. He said, snipers don't factor in Coriolis. If they did, then pilots would have to do the same, but they do not. Using snipers but ignoring pilots is typical obfuscation. No, actually, the snipers in the sniper books, it does clearly say that in a lot of situations, the Coriolis doesn't need to be accounted for, because there's a lot of things that are more like wind, and certain other factors are a lot more powerful. So a lot of snipers that maybe don't change like latitude, that are shooting from one latitude roughly, they probably would never have to encounter Coriolis, because they're even like you're saying with the bullet. I mean, all of that, there's many factors that a sniper will factor in. And yes, Coriolis is one of the last factors because it's so subtle. He's asking about why planes don't. Well, he's asking you.
But again, in the planes, I mean, again, planes there is a correction in planes for Coriolis. In fact, the amount of fuel and energy, it's just a small correction. So again, this is information that's very accessible online. You can see absolutely that planes correct for Coriolis going, yes, they do.
All right, man. All right.
And if it doesn't have to be the pilot necessarily. I mean, I'm not a pilot. I've just seen the information. So it can be automatically like built. Planes these days have a lot of things automatically factored in, right?
So then if a pilot then went off of autopilot and went manually, they would have to know to do that.
Well,
they don't account for course.
Well, they're following a bearing though. They're following a course. So again, 0.15 degree. I mean, it's a 0.15 degrees is such a tiny thing. So if they're just following their bearing, I mean, that's not much of an angle.
3,000 kilometers over a 5-hour flight.
Show me the numbers. I got the actual numbers.
I'll
That's
send
not
you the
correct.
numbers. I have the actual numbers. Yeah. So we can move on though. Nominal says, thanks for the debate. Then he said, the invisible matter we cannot detect is called dark matter. A quote from NASA. The invisible matter we cannot detect is called dark matter. That's from NASA. So they can't detect it.
What's the question? I mean,
He's saying that you said they could detect it, but they can't detect it according to NASA.
we see the effects of it. We know that the rotation rates are going, at a rate that that the baryonic matter can't account for.
Okay.
So again, it's yes. Do you guys have everything figured out? You don't even know if the sun's inside or outside the dome. I mean, I've had people say that's outside. Some people say it's inside. So to be critical of these very accurate theories that we have, and yet you guys don't even know how far up your sun is or where it is or what's going on outside the dome or outside the wall. I mean,
it's not an accurate theory. You don't know what 95% of it is. So
well, you guys don't even know where you are in the whole. I mean, where is the flat Earth in this void? I mean,
what void?
Well, I'm just saying that's exactly what is out. I mean, you don't. So I'm saying you're criticizing the globe model because we're still learning about the universe, but we have actual science that can predict, make excellent predictions, can build all the technology
Bro, come on,
around you. I'm just saying
Don't make this weird, Bryant. Don't make it weird, bro. You don't have any predictions, man. They were all wrong. So it's all good.
They're all wrong.
You don't have 95% of the universe even theoretically explained. You don't have all kinds of perfect predictions.
I told you that that's large scale effects within our inertial system of the solar system and the Earth. What we have works very well, provably.
Okay, it was actually designed after we saw what they allegedly claim happened. All right, so the Boston Runner says, I don't know if this is a question. It says, Austin speaking truth about the place we live. Anyone that can't see that has to first set aside what they think they know to actually research the deceptions launched at all of us over time. It can be scary at first, but peace and freedom do come. Okay, and that's not really a question, but thank you very much for the generous donation, the Boston Runner. That was very nice. Thank you, Dave, for the $10 donation. Dylan Schumacher says, what causes wind? Same as clouds? I don't know who the question's for. He's asking you.
It's fluid dynamics. I mean, it's temperature, pressure, a lot of things like that. I mean, it's a very complex. I mean, we definitely have a very complex atmosphere. There's no question about it. Okay. With water and land. And I mean, just a lot of factors go into that.
Do you agree clouds are electrostatic?
I don't think no, they're not just electrostatic. They produce, like you said, through you weren't totally incorrect with the friction, the way that the charges will get. I mean, that is correct, but it doesn't mean that the clouds themselves are electrostatic. The clouds are made of water vapor but the friction will create the lightning.
Create what?
But it doesn't mean that that's the downward acceleration. Just because we have electrostatics on the Earth doesn't mean that that's gravity or that that's where the downward acceleration comes from. I mean,
okay.
You need the evidence. Again, you need to have some studies or some evidence to.
Bryant, do you remember I asked you this question like 20 times in this debate? Maybe 5, right? I said, so the only way you can have an electric gradient of equipotential values, right? 100 volts per meter, equipotential increase, electric gradient. Wait, is the only way you can have it is to have 2 Gaussian surfaces, one on the bottom and one on the top.
But it's not. I told you weren't even. I guess weren't listening when I was explaining that it's only about 100 volts per meter for the first 120 meters. Okay, and this, by the way, is right from one of those corona motor type of diagrams. It starts to drop off very quickly after that. And again, the conductive layer you're talking about is the ionosphere, which, by the way, if you go, you can find tons of studies to validate the ionosphere.
So the ionosphere is the second Gaussian surface.
Well, I wouldn't call. I mean, it's a highly conductive atmosphere.
Is it? But you agree you have to have 2 Gaussian surfaces, though.
So when you say what are you trying to say by Gaussian surface?
It can transfer or retain charge.
Okay, that's
a closed surface that transfers or.
That's like a highly conductive surface, or wrapping around the globe. And
the ionosphere is a surface.
It's not a surface; it's a layer of the atmosphere. I'm just saying
it's all good.
It's a conductive. It's not a surface. It's a very big. But I'm just saying when you get to the first part of the ionosphere, that's when the electric field starts to go. I mean, because when you got a conductor, the electric field goes to 0 in a conductor. You know that, right?
Yeah. Do you agree there's a downward electric flow on the Earth, though?
Actually, downward and upward all day long. It's going down and up and sideways across. Again, if you look at the global circuits, you'll see it's this whole up and down and sideways.
I don't believe in the globe, Bryant. Stop saying globe. Richard Feynman says that it goes like many, many kilometers in the air. I don't know where you're getting this 120 meters thing.
No, it's he said 50 kilometers.
Okay, so then what are you talking about when you say 120 meters?
No. I said at 120 meters, the 100 volts per meter approximation breaks down. I didn't say that it stops. I just say that it goes to like 50 volts per meter, then it goes to 30, and then it drops off to almost 0 at about 50 kilometers.
Okay, that's what you're saying.
Your whole 100 volts per meter thing is only valid for the first 120 meters. I'm not saying it stops there. I'm just saying it starts to go down very quickly, and we know gravity goes down very slowly. So again, it just can't explain the downward acceleration. It just doesn't work.
If something's more dense, it goes down. Things that are less dense go up. That's the primary cause of the buoyant force. But what sets the up and down vector is the downward electric force. It's all good because we would talk forever. Maybe we can have another conversation again. And I think.
Anyway, I think I got to.
All right, let me just read the last few off. Okay, so Dave says, please provide a direct measurement of curvature over a body of water, at least 10 miles, showing the 66 feet elevation drop. Just, you can answer real concisely.
I wasn't going to talk about curvature today.
Okay. He doesn't want to talk about curvature. It doesn't exist, Dave. Come on, man. How are you going to set him up like that? I'm just okay. Goldie says it's flat. Thank you for the $5. Give me the gravy, says Bryant. Is there a chance you're wrong?
I don't think so, no.
No chance?
You think that bars people from
the earth is flat? I mean, I don't know. I'm not wrong. I mean, it's definitely not flat. I just have too much evidence. I can't. I mean.
So there's no chance?
There's no chance. I mean, based on what I know, there's no chance. No, it just can't.
Well, you can never learn anything new if you think you already know it. No one goes looking for something they think they already know, right? All right. But the Boston Runner says that things in the sky are spiritual in nature, not rocks and gas we can go visit. Do you not realize that? The CGI images of planets in space are not real at all.
Actually, I've had a telescope, and what you guys call these images of planets is bokeh. You know that, right? It's out of focus photography.
That's what they say, but digital is different than analog, and it seems to show a different spectrum of the light.
I've seen it with a telescope. I've seen Saturn as it looks.
That's analog.
It's not analog. It's with an actual telescope, not with a P900 camera.
Which is analog versus digital, yeah.
You think P900 cameras are meant for astronomy?
They're just digital pick up a different type of spectrum. So anyway, question the answers. You can see them way too clearly to just be out of focus. That's just a cop out. It's digital versus analog. Question and answer says, why don't we?
I can use a candle, and I can use a candle behind a light source and create those same patterns with a candle.
Did you know that I can get a bunch of electrostatics and I can blow candles out with my fingers? Everything's electric. All right. Anyway, question the answer says, why don't we see complete different stars every 6 months? How can we see Mercury at night, stellar eclipse, and how do railguns work? It's not a conspiracy. It's compartmentalized ignorance, ultimately spiritual.
What do you mean? Around the ecliptic, we do see difference through the times of the year. We see along the equator, all the that's the basis of astrology. All the constellations are constantly changing throughout the year.
You're saying we would see all kinds of totally different set of stars every 6 months. We'd be looking the other way.
No. It's because we're rotating around the sun. That's why.
Okay. Yeah. So you'd be looking in a totally different part of space.
Wouldn't you be looking the opposite direction?
So I mean, that's what I'm saying. It's because we are orbiting the sun that we go through the different constellations throughout. But now the North Star, again, we can go on and on. Let's just.
Okay. Fair enough. Okay. So yeah, he asked a few things. Stellar eclipse, but anyway, this guy said what? So the sun's not actually there. It just looks like it's there.
Well, you understand with sunsets, you get refraction, that the sun is already set, but you can see it after it's set because of refraction.
I understand that's what you claim, yeah.
No, that's light. You guys use refraction all the time. That's light bending, atmosphere. It's a well-known phenomenon that light bends through different media. I mean,
no, you can't prove that the sun's not where you see it. You just say that. So,
well, I think I can prove it, but
the way they prove it is they take their equation and they say, according to the globe Earth math, it should be down beneath the Earth, so it has to be refracted. Here's how much the difference is. It refracted this much. That's not proving anything.
Well, anyway, that at nighttime you got to go through a lot more atmosphere because the light's skimming through the whole atmosphere. So that's why you get a red sunset, because the blue gets scattered and filtered out because you're going. That's why there is more refraction at night, because you're going through a lot more atmosphere. when the
All
sun
right.
is setting.
Angel asked me, why does the weight change at the equator? I think we're within a vortex of an ether field, and I think that there is actually a translation of motion from the sky, and within that ether vortex, based on your altitude and your positioning out from the center, you would have a difference in downward pressure.
Show some evidence for that. I'd like to see the evidence.
I have the same evidence you do. You just claim it's gravity that can't be proven.
It can be proved. It's a centrifugal force. It's very well measurable. It's very simple to calculate, actually.
Okay, so when you say measure and calculation, those are two different things. Obviously, you just beg the question
You
and
can
assume
take
it's there.
You can take a scale and measure and weigh things at the equator, and you'll see exactly they correspond to what the centrifugal acceleration of a sphere gives. Yes, they do.
Once again, even Einstein would tell you that the centrifugal and Coriolis effects observed on the Earth could be because the sky is moving around a stationary Earth. I don't know why you keep ignoring that. So anyway,
that's not evidence, though. That's just a quote.
that's what your belief is also. You have the same quote unquote evidence. You interpret it one way, and then you pretend there's no other explanation as proof. And I'm explaining to you that even Einstein himself says that's not true.
Okay, if he says that quote and you believe it, you got to supply the evidence to show that it does that.
You provide the evidence that it's the Earth spinning.
Well, I did. I mean, I
No, my point is Einstein explains that all the stuff that you proposed would happen if the Earth was stationary and the sky was moving around it.
Well, you know, one of the quotes from Einstein, he actually said that's preposterous. He says, "Since I have come to believe that the motion of the Earth cannot be detected by any optical instrument." So you guys say that, but then you forget to leave out.
Yeah, he follows it up with, but we were moving around the sun.
Right, through the revolving around the sun. Right.
That's not evidence. That's him just saying that.
Begging the question, just
exactly. But you guys are putting out quotes like that's kind of quotes are not evidence. I agree. I'm just saying.
But you still use relativity. The person that wrote it says applying relativity, you would get the same effect. I don't understand. I don't think you're listening or not trying. The person that gave you your belief system of relativity, he said that according to relativity, which you still use to this day, according to it, if the sky was moving around the Earth, you'd get all the same effects.
One quote. I mean, Leonard Susskind has said, well,
there's dozens of quotes.
I mean, Leonard Susskind gave a little idea of a big, thick, flat Earth. And if it was 7 miles thick, you could calculate the gravitational would work for a while. But it doesn't mean that he believes that the Earth is flat. He's just
Brian, you should go to our Flat Earth Summit, bro. TEMMS.live. You should go check it out, man. You can use Witsit 50 as your coupon code, or Jaron 50. Yeah, and you can just come check it out. Virtual online summit.
Any other questions? I just want to make sure because I gotta.
Okay, yeah, sure. I think this maybe is the last one. Thank you for being here. Don't be too close. He said at Bryant. Thank you for being here. Don't be too close-minded.
Yeah, I'm not close-minded.
Then someone said, why haven't constellations changed in all the years?
They have.
He says they have changed. Okay.
Well, we can talk about that.
Yeah, he says doesn't want to talk about curvature. I don't blame him.
Well, again, I mean, I just don't want to get it because we're gonna end up talking for a half an hour.
Fair enough.
We'll get.
But again, if you want to make that a topic for next time, I'll prepare for that topic.
Cool, Brian. Don't you feel like this was pretty cordial overall, and then everyone got to kind of talk, and there was.
I like it. I like this format. It's very nice.
Cool. So thank you for coming on, man. I think it went pretty good overall. I think it kind of got like a little worked up maybe here and there, but hopefully everyone got to hear both sides relevant to the subject, and they can make up their own mind. And maybe we can do it again in the future. We can chat maybe.
Absolutely. Thanks for having me on. I really appreciate you guys bringing me on. And I mean, it was fun. It got heated, but I still enjoy, sharing my side of the truth. And as a former physics teacher, I just like people to be excited about science because you can actually build, make, and do a lot of wonderful things with science. It's not just about accepting a philosophy we can apply it to actual engineering and building things.
Sure. I agree. I think science is great.
Cool. All right, man.
All right. Much love, man. Thanks for coming on.
Much love, guys. I appreciate it. Thank you.
Yeah.
Later.
Bye-bye.
All right, brother.
That's
Thanks
fun.
for doing that.
Yeah.
Yeah. I just got another super chat.
Hard with people like that.
What?
It's hard with people like that because he's just not going to see it. So he doesn't realize that he just keeps going to the same well, and the centrifugal force. And again, these things have been set up for them, in my opinion.
Yeah. I mean, what can you do, man? I got this. Let's see what this says. Philosophical bias is the one bias that science cannot avoid. Peer-reviewed, Frederick Anderson. You dropped a peer-reviewed quote just a little late. He just left. Yeah. Yeah, I agree with that.
I mean, it's brilliant that they came up with this idea that if you give them all the truth first, or the so-called truth, that then anybody trying to come and say that that's a lie is required to provide the new proof. Like, that we're supposed to complete in 5 years what governments took 350 years, kings and queens money, government money, sending out ships full of thousands of people to map coastlines. How the hell would we do that?
It's crazy, man.
It's literally impossible for us to do what he wants us to do.
I really like your adoption analogy. I've been saying it a lot. Like I ruffled through my parents' closet, found some adoption papers. Yeah. I'm like, hey, Jaron, guess what, bro? My whole life has been a lie. I just found out I'm adopted.
Nope. Who's your real family? I
don't know who my real family is yet. I'm just trying to.
Too bad that's your mom and dad. Go deal with them.
No, bro, it's the paper. I have the evidence right here. It's their adopted.
Your family raises you fine. They raised you fine, right?
But they're not my real parents. That's all I'm saying.
Food. It works. You can still live a life. Then it's fine. You're fine.
Okay.
It works well.
So until I figure out my real parents, they're still my real parents, even though I have proof that they're not my real parents.
It works, right? You have a bed to sleep in and you get food. Then
how's it going to change my life anyway, right?
Classic.
Yeah, that's what. I think it really elucidates the problem.
Thing. That's what they want. I love the answer. If you tell somebody you're flat earth, they're just like, wait, how does the whole universe work then?
Yeah. Oh, you don't know? Got you, you stupid flurf.
I knew you didn't know anything.
Yeah, it's wild.
Funny stuff.
Well, cool. Thanks for doing that, man.
Duck out.
Yeah. All right, much love, brother. We'll hang out soon, of course.
All right, yeah, we got a lot to do. Talk to you later.
Peace out, bro. All right, thank you guys for kicking it. Hopefully you enjoyed that. Checkmate flurf, yeah, it's a funny meme. Cool. Yeah, like I said, I hope you guys enjoyed it. Slam dunk. Oh, thanks. When did you actually find out you were adopted? I'm not adopted. It's all relative, yeah. Missed it. Witsit, however he spinned it. I'm sure you winned it. Look at this guy, got bars out here, bro. Missed it, Witsit, however he spinned it. I'm sure you winned it. Thank you for the super chat, brother. Much love. All right, cool. So I'm gonna go get a little bite to eat. It's kind of late. Thanks for kicking it. Hopefully you guys enjoyed. Basically, my summary of the situation is you saw how it goes. I mean, no one really ever answers the questions directly. Yeah, there's a downward electric gradient on the Earth, bro. And electrostatics is what holds all matter together. Everything that exists is electrostatic. And there's no evidence that the Earth is spinning. There's no evidence that it's curving. There's no evidence that you can have pressure next to a vacuum. Where gravity claims to be the strongest on the surface, it would fill the vacuum violently. How's it going to go where gravity's weaker beside a vacuum? And then, so anyway, thank you guys for kicking it. I'm going to plug Flattoberfest. So you can go to, that's an in-person event. Kai and I will be debating flatearthfestivals.com. And then you can use the code Witsit10 to get a discount. And then also, I'll drop the links. You can go to temms.live. Wait, I actually don't remember what it is. Yeah, temms.live. That is the True Earth Mount Meru Summit. And you can use the coupon code Witsit50 to get 50% off. And that's a cool little online summit. We have epic speakers. I think we'll be dropping another announcement here soon. So yeah, hope you guys enjoyed it. And we'll try to do more stuff like that. I saw some people become members. Shout out to all the people that became members. Thank you guys. That was epic. I saw like 5 or 6 of you guys become members. So thank you all. And then we will be doing some stuff that's member only perk in the future. I think I got some more debates. I'm trying to get like the NASA guy to come on to do like an interview. And I'm trying to have set up some more credentialed physicists, astrophysicists, and astronomers debates. I think we're going to try to do something like that more often. So hopefully you guys enjoyed it. And yeah, cool. Thanks for kicking it. Seek and speak truth unequivocally, and the weak find contentment in the consensus of ignorance. So don't worry about what other people think. Like sometimes the truth seems crazy at first. The more you start to really look into it, you find out. Like for example, with the Earth, it's a house of cards. Like the Earth is not a spinning ball that's tilted, wobbling, going around the sun in a vacuum. All the evidence shows us the opposite. And then like even the people that brought it to you will tell you, oh, it's just a philosophy because we don't think it makes sense that the Earth could be special and unique in its positioning in the sky. Well, that's a weirdo philosophy. Don't put it on to me like it's science. And so think for yourself, bro. Don't let people make their own philosophies and then force them onto you. You're allowed to make your own philosophical decisions and determine your own worldview in life. And that's really why I talk about the Earth specifically. That's why I do this. I want them to realize it was a philosophy put onto you. the idea that the earth is a sphere comes from the idea that, for one, Democritus, a Greek philosopher, said everything's comprised of indivisible little atoms or spheres. And then it moved to, oh, the sky must be full of spheres. Oh, the earth must be a sphere because the perfect shape is a sphere. That's literally where this all started from. The perfect shape is a sphere, so the earth must be a sphere. And then it turned into, oh, Copernican principle, the earth has to be going around the sun in this gigantic universe because it can't be a special, unique position because that would mean it's created. And that's weird. So there you go. If you want to support the channel or you enjoyed the debate and want to help a brother out a little bit, I could use it at the moment quite a bit. $ Witsit gets it on Cash App, or you can go to paypal.me/inaworld. You can also join to become a member down below. You can go to patreon.com/Witsit gets it. And so that'll be greatly appreciated. If anyone goes to $ Witsit gets it on Cash App or paypal.me/inaworld, I'll read the I'll read the donations off in the next stream. I plan on doing a stream tomorrow. So until then, hope you guys enjoyed it. You know, if you get reviled for speaking the truth, rejoice, for they did that to all the prophets before you. Normally what's popular is not true, and the truth is not popular. So it's all good. That just kind of comes with the territory. So you should kind of understand that's going to happen if you're actually representing the truth. So until next time, I'll catch up with you guys later. Peace.
That's for Israel. Wonder, is it real? Rappers acting say they high, say they simple pills. Glorify suicide so they get the deals. Big pharma set it up, had to flip the pills. Control the music industry until the scripts get filled. Geopolitically, yeah, we in the field. That's for Israel. Wonder, is it real? Took the way you saw the world, then distorted it. Now you think you wanna rock that twirl somewhere orbiting. Theories disproportionate, the truth distorted quick with a forceful grip. They force them as simple that we absorb it quick. Took the people's signature, the mean extorted it. They forging it, if news anchors informants who informing them. There's a surplus, but they tell us there are shortages. Credit economy mortgages, dollar that's supported with empty fortresses. But what's important is this reporting ships important. Yes, of course it is, but extortion is in accordance with an assortment list of foreign tricks we ignoring, which informing this, informing this. It looked like we were snoring tricked. Pedophilia and the government endorsing it. Yeah, eugenics is exactly what abortion is. You just vilify those insubordinate. Way to matrix engineer, that's unfortunate. Geopolitically, we in a field. That's for Israel. Wonder, is it real? Rappers acting say they high, say they simple pills. Glorify suicide so they get the deals. Big pharma set it up just to flip the pills. Control the music industry until the scripts get filled. Geopolitically, yeah, we in a field. That's for Israel. Wonder, is it real?